What if everything you believe about time is wrong? What if the concept we hold dear, time as a constant, unyielding flow, was nothing more than a trick of perception? In this exploration, we embark on a journey through history, science, and philosophy to unravel the very nature of time, from its earliest theoretical origins to the latest cutting-edge discoveries that challenge everything we thought we knew. We'll investigate not just the role of time in our everyday lives, but its deep and intricate connection to the universe itself. Prepare to venture beyond your traditional understanding of time and step into a world where the past, present, and future could be fluid, ever-changing, and possibly even illusory. Imagine waking up each day to a world where the concepts of past, present, and future are no longer fixed points on a straight line, but rather fluid, ephemeral moments that dance and intermingle within a vast ocean of possibilities. What if time was not a linear progression, but a complex, malleable construct that we as human beings create to make sense of our experiences? This is an idea that many scientists and philosophers have begun to entertain, that time, as we perceive it, is not a universal truth, but a mental framework we rely on to navigate the world. As we venture deeper into this exploration, prepare yourself to engage with a reality where minutes, hours, and days might stretch, bend, and fold in ways that defy all conventional logic. The linear understanding of time that we take for granted might be just one possible interpretation of something far more complex. It begins with a simple question: is time truly linear, or could it be something entirely different? For most people, time is experienced as a straightforward path, one that moves from the past through the present and into the future. This is how we perceive it day after day, hour after hour. But as modern science and quantum mechanics have revealed, this understanding is incomplete. Rather than a single, unyielding line, time may be better understood as a fabric, a multi-dimensional tapestry where different threads, intertwined and interdependent, stretch and contract based on factors like speed, gravity, and motion. Take, for example, the theory of relativity, which teaches us that time does not flow uniformly throughout the universe. If we could travel close to the speed of light, we would experience time very differently than someone standing still. To them, our clock would seem to tick more slowly, while our perception of their time would appear to move faster. If you were to embark on a journey into deep space, traveling at incredible speeds, you could return to Earth and find that far more time has passed here than what you experienced during your journey. This phenomenon is not just an oddity, it's a testament to the idea that time is not fixed. It's fluid, subject to change based on perspective. This brings us to an even more mind-bending concept: time loops. What if time wasn't a one-way street at all? What if it could fold back on itself, allowing moments to repeat, overlap, or even coexist? Could the future bleed into the present? Could the past revisit itself in strange, cyclical patterns? These ideas, once confined to the realm of science fiction, are now being taken seriously by physicists who are grappling with the complexities of space-time. If time is not a rigid, unchanging flow, could it be that the very nature of reality itself is far more flexible than we ever imagined? In the pursuit of these questions, the very fabric of our understanding of reality is being tested. What we once thought of as the flow of time may not be a flow at all. It could be a construct, a product of human perception, shaped by the need for structure in a chaotic universe. The more we probe into these mysteries, the more we uncover a deeper, more intricate understanding of time. We find ourselves not just observing time, but actively questioning its implications, its mysteries, and its place within the universe. Time is undeniably one of the most fundamental aspects of human existence. It serves as the skeleton around which we build our lives, providing structure and rhythm to our existence. Without it, we would struggle to function. Imagine waking up in the morning without any sense of time. No clock to guide your movements, no appointments to keep, no structured day. Chaos would undoubtedly reign. Time helps us organize the world around us, allowing us to coordinate our lives, our work, and our social interactions. From the moment we are born, time becomes our constant companion, shaping the way we live, think, and interact with others. This reliance on time isn't just a product of modern life, it has deep roots in nature itself. The rising and setting of the sun, the changing of the seasons, the cycles of the moon, All of these rhythms are natural markers of time, and we have, over millennia, learned to harness these cycles to organize our lives. We've created clocks, calendars, and schedules to quantify these cycles, to turn something abstract and elusive into a manageable, predictable resource. The development of these tools has allowed for a shared understanding of time across cultures, shaping everything from agriculture to religious practices. But time is not just a tool. It's a concept with deep philosophical significance. Time is woven into the very fabric of our being, shaping how we think, how we feel, and how we relate to others. It's the lens through which we view the world, how we remember the past, how we experience the present, and how we anticipate the future. Time is the foundation of human memory. Without it, we wouldn't be able to distinguish between the events of yesterday and those of today. It is what allows us to learn from the past, to plan for the future, and to make sense of the present. Different cultures, however, perceive time in different ways. For many societies, time is linear, a straight line from the past into the future. Yet in others, time is seen as cyclical, a recurring loop echoing the rhythms of nature and life itself. These differing perceptions shape how people live, how they celebrate, and how they relate to one another. In a linear culture, for instance, people may be more focused on progress, on moving forward, while in a cyclical society, there might be more emphasis on reflection, repetition, and tradition. The impact of time isn't just philosophical, it has tangible consequences in the physical world. Consider the phenomenon of time dilation, a consequence of Einstein's theory of relativity. Time passes differently in regions of strong gravity. Near a massive object like a black hole, time slows down relative to an observer far away. This isn't just a theoretical concept, it's a real effect, observable in the universe. Time, in this sense, is not just a human construct, it's a physical property of the universe itself, shaping how we experience reality. These insights into time, though deeply scientific, open up questions that stretch far beyond physics. They invite us to reconsider what we thought we knew about reality itself. If time is not the unchanging flow we once imagined, what does that mean for our understanding of the past, present, and future? What does it mean for our place in the cosmos? These are the questions that scientists, philosophers, and thinkers have been grappling with for centuries, and we are only beginning to scratch the surface of answers. In the course of human history, time has always been a guiding force, an invisible hand shaping the course of events. Early civilizations, such as the Egyptians and Mayans, carefully studied the movements of the stars and the sun to create calendars, marking the rhythms of life. Their understanding of time influenced everything from agriculture to religious practices. As societies progressed, so did our understanding of time. Philosophers like Aristotle and St. Augustine pondered the nature of time, debating whether it was infinite or finite, continuous or segmented. With the rise of modern science, especially during the Enlightenment and the Industrial Revolution, time took on an entirely new significance. The Industrial Revolution, in particular, marked a major shift in how society viewed and used time. As factories sprang up, synchronized schedules became essential for efficiency. Clocks, once used only for specific purposes, became central to daily life. This mechanization of timekeeping revolutionized everything from how we work to how we socialized. But this new precision also came with a downside: the stress of time management, as people were expected to optimize every minute of their day. Today, as we stand at the crossroads of physics and philosophy, we find ourselves questioning the very foundations of time itself. Is it real or is it an illusion? Does it flow or does it bend and stretch according to the nature of the universe? As we continue to explore these questions, we might find that our understanding of time is just the beginning of a much larger mystery, one that could change the way we see the past, present, and future forever. The exploration of time, particularly in the 20th century, transformed the way humanity understands its very existence. As science advanced, time emerged not as a simple, unchanging backdrop, but as something far more fluid and interconnected with the universe. One of the most significant breakthroughs came with Albert Einstein's theory of relativity. This theory, which revolutionized physics, challenged the conventional belief that time is a constant. Instead, it proposed that time is elastic. Its passage is influenced by the speed of an object and the gravitational pull it experiences. For instance, imagine two clocks, one situated on Earth and the other aboard a spacecraft traveling at near light speed. The clock on the spacecraft would tick slower compared to the one on Earth. This is not merely a hypothetical example, but a scientifically confirmed phenomenon, and it demonstrates that time is far from universal. It is flexible, stretching, and compressing depending on where you are in the cosmos and how fast you are moving. However, relativity wasn't the only field to challenge our understanding of time. The advent of quantum mechanics brought with it even more bewildering ideas. At the subatomic level, particles behave in ways that defy the classical notions of time. In this realm, particles don't always follow a linear progression. Some theories suggest that at these scales, time itself may not exist in the way we think. Instead, time could be an emergent property, something that arises from the interactions between particles rather than a fundamental aspect of the universe. This idea leads us to a startling possibility. Time, as we know it, may be an illusion, our perception of its steady flow a mere construct of our consciousness. Moreover, quantum mechanics introduces the concept of superposition, where particles can exist in multiple states at once. In this view, time is no longer a steady, unidirectional flow, but a series of possibilities. The act of observation plays a crucial role as it collapses the particle's multiple potential states into a single reality. This implies that the linearity of time, where events occur in a clear sequence, past, present, future, might be an oversimplification of how the universe operates at its deepest level. Equally perplexing is the concept of quantum entanglement, which describes how two particles can become so deeply connected that the state of one instantly affects the state of the other, regardless of the distance between them. This instantaneous connection seems to disregard the limits imposed by time and space, suggesting that information can transcend the traditional constraints of temporal flow. In this world, time itself can become fluid, stretching and contracting, becoming disjointed or even non-linear. Thus, quantum physics compels us to reconsider our traditional perception of time and to acknowledge that it may be a more multifaceted and subjective phenomenon than previously imagined. As we shift from quantum mechanics to relativity, time continues to evade easy understanding. In relativity, time is not a separate entity, but is woven into the fabric of space itself, forming what Einstein described as space-time. Space-time behaves much like a flexible mat that can bend and stretch when mass is placed upon it. Imagine a massive object, like a planet or star, sitting on this mat. The weight of this object causes a distortion, curving the fabric around it. This curvature of space-time influences how time is experienced. For instance, the closer an object is to a massive gravitational source, such as a planet or black hole, the slower time appears to pass relative to an object farther away. A clock on a satellite orbiting Earth, for example, will tick at a different rate than a clock on the surface of the planet, illustrating how time is not experienced uniformly across different locations in the universe. These revelations have profound implications for both science and philosophy. They raise fundamental questions about the nature of reality itself, about the human experience, and our place within the cosmos. If time is not a fixed entity, but something that bends and twists according to speed, gravity, and observation, then how do we experience it in our daily lives? Our perception of time is built on the assumption that it moves in a straight line. The past leads to the present, which inevitably gives way to the future. This linear progression is integral to our understanding of cause and effect, and it forms the foundation of how we organize our lives, from setting alarms to planning for the future. But as we peer into the depths of physics, we find that this understanding is increasingly challenged. Scientists refer to time as an illusion, not to dismiss it, but to encourage us to reconsider the way we perceive it. In our everyday lives, time seems to flow inexorably, each second slipping into the next. However, as we delve deeper into the realms of relativity and quantum mechanics, we see that time is not so simple. The movement of objects through space and time alters their perception of the passage of time. As an object approaches the speed of light, time slows down for that object, relative to an observer at rest. This counterintuitive behavior defies the traditional understanding of time as a steady, unchanging measure. Similarly, quantum mechanics suggests that time is not an absolute measure of reality, but something that can be influenced by the observer and the context in which events unfold. Time, then, is not a simple, uniform experience. It is a concept that intertwines with the very fabric of the universe, shaped by the laws of physics and our understanding of them. Our intuitive sense of time is based on the way we experience it day after day in a predictable and linear manner. But as we uncover more about the workings of the universe, it becomes clear that this understanding may only scratch the surface of a far deeper and more complex truth. Time may not be what we think it is. It may not be a constant, but a shifting, bending, and malleable concept that behaves differently depending on our perspective and the forces at play around us. As humanity continues to investigate the mysteries of time, we are reminded that our place in the cosmos is far more intricate than we may have ever imagined. Time, once seen as a simple measurement of moments, has proven to be a profound and elusive concept. It challenges our most basic assumptions about the nature of reality, inviting us to question not just how time works, but how we perceive and experience existence itself. Each new scientific discovery about time adds another layer to our understanding, pushing the boundaries of human knowledge and drawing us closer to the mysteries that lie at the heart of the universe. Whether in the realms of relativity or quantum mechanics, time remains one of the most fundamental and enigmatic aspects of the human experience, a concept that continues to evolve as we venture deeper into the mysteries of the cosmos. Time, as we experience it, is far from the simple, unchanging flow we might assume it to be. What we often take for granted as a constant force, marching forward unimpeded, is in fact an intricate, ever-shifting phenomenon that is deeply influenced by the forces of gravity and motion. This understanding begins with the theory of relativity, which unveils a staggering truth. Time is not universal, but relative. It varies, changes, and bends depending on where you are, how fast you are moving, and the gravitational influences you are under. In a sense, time can be as unique as the observer experiencing it. This concept, though initially counterintuitive, suggests that the very experience of time itself is fluid, shaped by the forces of gravity and velocity. The notion that time could be experienced differently based on one's motion or position challenges the simple notion that time is the same everywhere. In fact, it reveals a profound complexity that demands a deeper reflection. Time, it turns out, is not a singular, unalterable entity. It becomes instead a personal experience, uniquely shaped by the conditions each of us faces. At the heart of this exploration lies time dilation, one of the most fascinating and mind-bending consequences of relativity. Time dilation occurs when an object moves at speeds approaching that of light or is situated in a powerful gravitational field. Under these conditions, time begins to slow down compared to regions where motion is slower or gravity is weaker. For example, imagine astronauts aboard a spacecraft journeying near the speed of light. To the astronauts on board, only a single year might pass during their voyage. However, upon returning to Earth, they would be shocked to discover that many more years have passed on the home planet. This illustrates how time is not a fixed quantity, but is instead malleable and variable depending on the circumstances. The faster you move, the slower time moves for you relative to someone not traveling at such high speeds. This phenomena pushes us to reconsider how we view the passage of time, not as a fixed linear process, but as something that stretches and contracts based on a variety of influencing factors. Moreover, time behaves even more peculiarly near black holes, where gravity reaches unimaginable extremes. Black holes are regions in space where gravity is so intense that not even light can escape, creating a boundary known as the event horizon. As an object approaches this boundary, time begins to slow down dramatically, at least from the perspective of an observer far away from the black hole. To an observer on Earth, a clock near a black hole would appear to tick slower and slower as it draws nearer to the event horizon, until at the very edge it would seem to freeze entirely. This phenomenon has profound implications for our understanding of time. It suggests that across the vast expanse of the universe, different observers might experience time in fundamentally different ways. This realization highlights the complexity of time itself, which, like the universe in which it operates, is dynamic, shifting, and highly dependent on the relative positions and movements of those observing it. Beyond these extreme cosmic scenarios, events like gravitational waves, ripples in the fabric of space-time caused by the acceleration of massive objects, also challenge our traditional views of time. These waves carry with them not only information about the cosmic events that created them, but also offer a glimpse into how the very structure of space-time is changing and evolving. Their detection opens up a new frontier for scientists to study the universe and the nature of time in a dynamic setting. The study of such phenomena reveals that time is far more complex than a uniform progression from one moment to the next. It is instead a living, breathing part of the fabric of the cosmos itself, shaped and influenced by speed, gravity, and the relentless churn of cosmic events. Philosophers, too, have long grappled with the nature of time, offering a variety of perspectives that reflect the deeper questions about reality and existence. In ancient philosophy, thinkers such as Heraclitus introduced the idea of time as an ever-flowing river, where nothing remains the same. For him, change was not only inevitable, but essential to existence itself. This view presents time as a dynamic force, a constant current that pushes forward, carrying all things in its wake. In stark contrast, Parmenides argued that time was an illusion, a mere construct of the mind. For him, true reality was unchanging and timeless, and our perceptions of time and change were merely superficial. This perspective set the stage for centuries of debate about whether time, as we understand it, is an inherent part of reality or simply a mental construct. As philosophy progressed, thinkers like Aristotle took a more practical approach, suggesting that time is a measure of change, intrinsically tied to the movement of objects. He proposed that our experience of time is tied to the events that unfold around us, organized into a sequence of past, present, and future. This idea of time as a structure that orders our experiences laid the groundwork for later theories in both philosophy and science. Moving into the modern era, Immanuel Kant introduced a radical shift in thinking. He argued that time is not an external reality, but rather a framework through which humans perceive and understand the world. For Kant, time is not something that exists independently of us. It is a mental construct that helps us organize our experiences and memories. In this view, our perception of time is not an objective reality, but a way our consciousness imposes order on the world. Kant's perspective challenges us to think about time in new ways. If time is not an external force but a product of our minds, does that mean it could be different from what we perceive it to be? Kant's insights align with modern scientific understandings of time, which suggests that time is far from the unchanging, universal entity we often assume it is. This opens up the possibility that our perceptions of time might be limited, shaped more by our minds than by any objective external reality. Kant's contributions force us to reconsider not just time, but the very fabric of our experience, our understanding of the world, our place in it, and how we make sense of our lives. Eastern philosophies, particularly those of Buddhism and Hinduism, offer yet another perspective on time, one that stands in sharp contrast to the linear view predominant in Western thought. In many Eastern traditions, time is seen as cyclical rather than linear. This cyclical understanding is often linked to natural rhythms, the changing seasons, the cycles of birth, growth, decay, and rebirth. Time in these traditions is not a straight path from the past to the future. Instead, it is a continuous, ever-returning cycle where moments flow into one another in an unending loop. This view challenges the Western conception of time as something that moves in one direction and highlights the interconnectedness of all things, suggesting that past, present, and future are not separate, but part of a larger, more fluid whole. In addition, Eastern philosophies, particularly in mindfulness practices, encourage a shift in focus from the concerns of the past and future to the present moment. This emphasis on being present helps to transcend the typical constraints of time and offers a way to understand the fleeting nature of moments. Through mindfulness, practitioners come to see that the relentless pursuit of time, always chasing after what is past or what is to come, can lead to stress and anxiety. True peace, according to these teachings, is found not in the future, nor in the past, but in the present moment. It is an invitation to embrace time not as a fixed measurement to be conquered, but as a dynamic, ever-shifting experience to be lived. In the end, time is far more than we often give it credit for. It is not just a ticking clock marking the hours, minutes, and seconds. It is a complex, multifaceted phenomenon that shapes the way we understand the universe, our existence, and even our minds. From the theoretical insights of physics to the deeply philosophical reflections on its nature, time is revealed as a far more elusive and powerful force than we have ever imagined. Understanding time in this way, both scientifically and philosophically, offers us a profound appreciation of the universe's intricacy and the fluid nature of our place within it. Time, it seems, is both a personal experience and a universal mystery, one that continues to unfold in ways that challenge our perceptions and deepen our understanding of the cosmos itself. The concept of Maya in Hindu philosophy presents the world as an illusion, suggesting that our attachment to time and events clouds our perception of true reality. This profound idea encourages individuals to reconsider the way they experience time, urging them to recognize that their past and future may not mirror their authentic selves or the deeper nature of existence. According to this perspective, time is not something rigid and unchangeable, but rather something fluid and illusory, subject to personal interpretation and spiritual growth. Through this lens, Eastern philosophy invites us to detach from the constraints of linear time, encouraging a more expansive understanding of the world around us, one that transcends mere measurements of hours, days, or years. The idea of time as a social construct rather than an absolute truth offers a gateway for a richer, more flexible engagement with life, and through it, we can experience a profound shift in how we relate to existence itself. Throughout history, different cultures have developed varying perceptions of time, deeply influencing their collective philosophies, lifestyles, and spiritual practices. The two dominant frameworks through which time is understood, linear and cyclical, offer a striking contrast that shapes not only individual experiences, but also community values, spiritual beliefs, and visions for the future. In linear conceptions of time, commonly found in many Western cultures, time is envisioned as a straight line, stretching from the past through the present and into the future. This view is rooted in a belief in progress, where every event is seen as building upon the one before it. New generations, equipped with knowledge and technology, are believed to push civilization forward, making each successive moment better than the last. Under this model, change is often perceived as an unrelenting march toward improvement. In contrast, cyclical perceptions of time, which are prevalent in many indigenous cultures and embedded in philosophies like Hinduism and Buddhism, understand time not as a linear progression, but as a repeating cycle. Events are seen not as isolated occurrences, but as part of an eternal loop. Life, death, and rebirth are phases within an infinite rhythm. This view is rooted in an awareness of nature's cycles, the changing of the seasons, the agricultural calendar, and the recurring patterns of birth and decay. Here, every ending is not truly an end, but rather a transition into a new phase of existence, suggesting that what we often perceive as loss or finality is simply part of an ongoing process. These differing approaches to time also profoundly affect how cultures approach history and change. In linear societies, history is often seen as a collection of milestones, each marking progress and achievement. The future is seen as a promise, always moving forward, and marked by innovation. In contrast, cyclical cultures often focus on continuity and tradition. They emphasize the wisdom found in cycles, drawing lessons from the past to guide the future. In these cultures, history is not about breaking away from the past, but about learning from it and honoring the eternal rhythms that sustain life. Ancient civilizations, such as the Maya and Egyptians, had highly developed approaches to understanding time that not only influenced their spiritual practices, but also shaped their daily lives. These early societies were keen observers of celestial events, the movements of the sun, moon, and stars, integrating these natural phenomena into their calendars. Time was not seen as an abstract or arbitrary force, but as something intricately woven into the fabric of their existence. The rise and fall of the sun, the phases of the moon, and the patterns of the stars were markers of time, guiding agricultural activities and religious rituals alike. This intimate connection between celestial rhythms and human activities demonstrates an early understanding that time, as we experience it, is deeply intertwined with the natural world. These ancient concepts of time have proven surprisingly relevant in the context of modern science. In particular, Einstein's theory of relativity has revealed that time is not a fixed entity, but a malleable dimension, one that can change depending on speed and gravity. This scientific breakthrough, which has transformed our understanding of the universe, bears a striking resemblance to the cyclical view of time held by ancient cultures. For them, time was not a straight path, but a series of repeating patterns, a perception that resonates with the fluid nature of time that science now recognizes. The study of ancient timekeeping methods, such as sundials and water clocks, further underscores the sophisticated understanding these cultures had of time's passage. These early technologies were not merely instruments for measuring hours and minutes. They reflected a deep philosophical engagement with the nature of time itself. While today's atomic clocks allow us to measure time with unprecedented accuracy, the rudimentary timekeeping methods of ancient civilizations were foundational to our current systems of measurement. This historical continuity between the ancient and the modern provides valuable insights into how scientific and philosophical understandings evolve to life, often building on the knowledge of past generations. As we explore the mysteries of the universe, whether it's the nature of black holes, the expansion of the cosmos, or the origin of time itself, we continue to grapple with the questions that thinkers from ancient cultures once posed. In doing so, we recognize that science, though it is often seen as a modern pursuit, is deeply connected to ancient wisdom. By revisiting these long-held beliefs about time, we enrich our current understanding and bring new dimensions to our exploration of existence. Our personal experience of time is similarly complex. Time is not just an abstract, external force. It is something we perceive with our senses and process with our minds. Imagine time as a flowing stream, with our conscious awareness navigating through it like a boat. We experience time through a variety of sensory cues: the sounds we hear, the sights we see, and the emotions we feel. When we are happy, time seems to fly by, while moments of boredom stretch out endlessly. This subjective experience of time happens because our brain processes information differently depending on the emotional and sensory significance of the moment. The more details and emotions we experience, the richer the memory we create, making time seem to pass faster in moments of significance. Conversely, during times of monotony or dullness, when fewer memories are created, time can feel as though it drags on. Additionally, our internal body clock, known as the circadian rhythm, plays a crucial role in how we perceive time. This natural cycle governs our sleep-wake patterns, energy levels, and alertness, helping us maintain a sense of temporal structure throughout the day. As we age, our perception of time may also change. Many people observe that time seems to accelerate with age, perhaps because as we grow older, our experiences become less novel, and our brain becomes more efficient in processing the familiar. Memory, too, plays a central role in shaping our perception of time. Our brains store events in memory, creating a personal timeline that we can reflect upon. However, this recollection of time is often subjective. For example, when we recall moments of excitement or joy, our brains often retrieve many vivid memories, making that period feel longer than it actually was. On the other hand, during monotonous or repetitive experiences, the brain may not form as many distinct memories, making time seem to pass quickly. In this way, our perception of time is an intricate interplay between external events, our internal processes, and the ways we store and retrieve memories. The fluidity of this experience challenges the rigid, linear concept of time that is often imposed upon us by society, inviting us to explore a deeper, but more personalized understanding of the passing moments. Our emotional state plays an undeniable and profound role in shaping the way we perceive and remember time. Whether we find ourselves in moments of joy, fear, stress, or sadness, these emotions intricately intertwine with our sense of temporal flow, often distorting it in ways we might not even consciously notice. High-stress events, for instance, are frequently associated with vivid, often overwhelming memories. These memories seem to stretch time, making moments feel as though they last much longer than they actually did. The intensity of such experiences triggers our brains to engage more deeply, recording minute details that would otherwise fade into the background. When we recall these events, the flood of sensory memories makes time feel prolonged, as if it somehow expanded during that brief interval. Conversely, positive or joyous moments tend to have the opposite effect, where time appears to speed up. During moments of happiness, our brains may process less information in a detailed manner, focusing instead on the overall experience, causing us to feel as if time flew by. This phenomenon can be seen when people talk about how quickly vacations, celebrations, or good times with friends and family seem to pass. But why does this happen? It's because during pleasant experiences, we are often relaxed, engaged, and less aware of the individual ticks of the clock. The result is that the passage of time feels compressed when we look back. On the other hand, during moments of intense stress, fear, or sadness, time seems to stretch indefinitely. Picture yourself in a tense situation, waiting for important news or enduring a scary moment. Each second feels unbearably long, stretching out into eternity. This is because our focus narrows during such emotionally charged events, and our brains process far more sensory information. Every detail, from the sounds in the environment to the subtle shifts in the atmosphere, is recorded in high resolution. When we reflect on these times, it feels as though we lived through an extended period, even though the event lasted only moments. This heightened awareness alters our perception of time, making it feel as if the seconds or minutes crawled by. This emotional distortion of time is not confined to moments of intense fear or excitement. In fact, extreme emotions can lead to a complete sense of temporal loss. In some cases, people become so absorbed in a task or overwhelmed by anxiety that they lose track of time entirely. They might be so engrossed in an activity such as a captivating project or a stressful deadline that they lose awareness of the passing hours. On the flip side, anxiety or dread about the future can make time seem agonizingly slow as we focus on the uncertain looming events ahead. This relationship between emotion and time speaks to the profound connection between our minds and the moments we experience. One way to explore this relationship between emotion and time is through everyday experiences. For example, imagine two siblings. One is preparing for a long-awaited road trip while the other remains at home. The sibling who is traveling will likely feel that time is passing slowly as they're consumed with anticipation and excitement. Every hour leading up to the journey may feel like an eternity. Meanwhile, the sibling left at home might experience time speeding by as they go about their daily activities, busy with their own tasks. In this simple analogy, the perception of time for both siblings is shaped not by the passage of minutes and hours, but by their emotional states and what they're focused on. Similarly, consider the experience of astronauts aboard the International Space Station, ISS. The astronauts orbit Earth at such high speeds that their perception of time becomes altered. They experience shorter days than those of us on Earth. The faster they travel, the more time seems to compress for them. When astronauts return to Earth after spending months in space, they find that their clocks tick at a different pace than those of their loved ones. Despite experiencing the same span of time, they have actually aged less than those who remained on the planet, a direct result of the effects of motion on time perception. This phenomenon, known as time dilation, exemplifies the malleability of time under extreme conditions, further complicating our understanding of time's passage. Now, think about how certain intense experiences can alter the feeling of time. A thrilling roller coaster ride, for instance, can feel as though it lasts forever. The adrenaline rush, the speed, the twists and turns all make the ride feel elongated. But contrast this with a simple hour spent waiting for an appointment, where the minutes seem to drag on endlessly. What's the difference? It's the level of engagement. During the roller coaster ride, your brain is processing a high volume of sensory information. Every shift, every sound, every motion. When we're highly alert, our brains take in more data, stretching the perception of time. During monotonous, less stimulating moments, however, our minds gloss over the details, making the same amount of time feel like it's passing faster. This flexibility of time perception is evident in our daily lives. Time is not just a constant ticking of the clock, but a fluid experience shaped by our emotions, activities, and perspectives. The advent of modern technology has only amplified this fluidity. Take, for example, smartphones. These devices are constantly at our fingertips, offering instant access to information and connecting us with others. As a result, we find ourselves in a perpetual rush, constantly moving from one task to the next. Answers are just a tap away, and the sense of urgency that comes with this connectivity creates an illusion that time is speeding up. We no longer have to wait for answers, making the concept of waiting seem obsolete. Time in this digital world seems to fly by. Similarly, social media platforms have revolutionized our perception of time. Events that once required weeks or months of planning now unfold in the blink of an eye, thanks to the instantaneous nature of online communication. This immediacy creates a faster-paced world where days can blend together in a blur of updates, messages, and notifications. The continuous nature of this digital world leaves us little room for pause or reflection, and this lack of breathing space contributes to the overwhelming feeling of time slipping away faster than we can grasp it. Moreover, technology has redefined how we organize our time. Online calendars and task management tools help us structure our days with military precision. We can plan out every minute, ensuring we maximize every hour. However, this efficiency paradox has a downside. The more we streamline our time, the more we fill our schedules to the brim. We become busier than ever, leaving little room for relaxation or downtime. As a result, time feels compressed and the hours become packed with activity, leaving us with little space to savor the present moment. The way we consume entertainment has also shifted dramatically. Streaming services, with their vast libraries of content, have reshaped our viewing habits. Rather than waiting for a new episode each week, viewers can now binge watch entire seasons of shows in one sitting. This shift away from anticipation and patience creates a culture where time spent waiting for something becomes an increasingly rare experience. Instant gratification becomes the norm, and as a result, our relationship with time becomes one of constant acceleration, where we are rarely forced to slow down and simply be. As our relationship with time becomes more complex, the notion of space-time, the merging of space and time into a unified concept, offers fascinating insights into the very nature of time itself. Space-time brings together the three dimensions of space and the fourth dimension of time, creating a new framework in which events are described not just by where they occur, but by when they take place as well. This combined model suggests that time is not a constant entity that flows in a straight line, but rather something more fluid, something that can bend and stretch depending on various factors. When objects move at high speeds or are near massive objects like planets or stars, the passage of time can differ from how it is experienced by someone else, far removed from these forces. For someone traveling near the speed of light, time moves at a different pace, slowing down relative to an outside observer. This phenomenon, as explained by the theory of relativity, demonstrates that time is not a universal constant. It bends and warps, influenced by speed and gravity. This concept blurs the lines we once believed existed between past, present, and future. Another profound example of time's malleability comes from the study of black holes, where gravity is so powerful that even light cannot escape their grasp. Black holes warp the very fabric of space and time around them. Time behaves differently depending on the proximity to a black hole, and as you approach the event horizon, the point of no return, time itself slows down. This phenomenon, known as gravitational time dilation, illustrates that time is not fixed but is deeply influenced by gravity's pull. The closer you are to a black hole, the more time seems to slow down. For someone far away, time passes normally, but for an observer near the event horizon, it appears to stretch out indefinitely. In these extreme conditions, our conventional understanding of time breaks down. What we once thought of as a simple linear progression of moments is revealed to be far more flexible and complex, shifting depending on the forces at play. The study of black holes and the broader concept of space-time offers profound insights into how time behaves not as a simple constant, but as an ever-changing, ever-flowing river of possibility. Time, it seems, is not just something we experience in a straightforward way. It is deeply interconnected with the very fabric of space itself, shaping the universe in ways we are only beginning to understand. The behavior of black holes offers a unique lens through which we can explore and challenge our most fundamental concepts of time. While traditional notions of time present it as a linear progression from past to present to future, certain theories in physics push us to reconsider this idea entirely. According to these theories, time may not follow a simple unidirectional flow. Rather, it could be far more intricate, with events interwoven in ways that defy our conventional understanding. By investigating the complex phenomena surrounding black holes, researchers are beginning to unravel the deeper mysteries of reality itself and explore how time might be intricately woven into the very fabric of the universe. This exploration promises not only to challenge our perceptions of time, but also to reveal new dimensions of the cosmos that remain beyond our comprehension. One area where our understanding of time faces significant challenges is in particle physics. Here, scientists are examining the very building blocks of matter: protons, electrons, and other subatomic particles. The environments in which these particles are studied are often extreme, involving incredibly high energies that bring the effects of relativity into play. When particles are accelerated to speeds nearing the speed of light, they experience time differently from us. For these particles, time literally slows down. This is not just a theoretical abstraction, but a very real phenomenon predicted by Einstein's theory of relativity. In essence, the faster a particle moves, the more its perception of time stretches, so that while it may experience a single moment, an outside observer sees that same moment unfold over a longer duration. This relationship between speed and time becomes even more mind-bending when we consider particle collisions. During these collisions, conditions are created that mirror those just after the Big Bang. At these incredibly high energy moments, the traditional understanding of cause and effect begins to break down. Particles may appear and disappear in what seems like an instantaneous process, suggesting that time itself may not be as rigid and ordered as we have always assumed. Instead, these collisions hint at a deeper complexity, where the past and future blur, challenging our conventional views of the passage of time. These interactions provide valuable insights not only into the nature of time, but also into the fundamental structure of reality itself. The more researchers delve into the microscopic world of particles, the more they are forced to confront questions about the very nature of time. What was once thought to be a steady, predictable flow is revealed to be far more elusive and interconnected than we ever imagined. By exploring these quantum phenomena, scientists are not only expanding our knowledge of the universe's smallest components, but also questioning the underlying assumptions about the universe's larger cosmic scale. In the realm of quantum mechanics, two particularly fascinating concepts, quantum entanglement and superposition, further challenge our traditional ideas of time and reality. Superposition, a key principle in quantum physics, describes the ability of a quantum particle to exist in multiple states simultaneously. Imagine a spinning coin, which can land as either heads or tails. While it spins, it represents both possibilities at once. It is only when we stop the coin and observe it that one of the outcomes is realized. This concept challenges the very notion of reality itself, as it suggests that particles exist in a state of potential until they are observed. And crucially, this raises important questions about how we perceive time. If actions are only defined at the moment of observation, then does time behave differently in the quantum realm? Entanglement takes this concept even further. When two particles become entangled, they share an instantaneous connection, regardless of how far apart they are in space. Changing the state of one particle will instantaneously affect the other, even if they are light years apart. This phenomenon suggests a kind of communication that transcends the typical linear flow of time. In our everyday experience, events unfold in a sequential order, but quantum entanglement defies this expectation. It hints at the possibility that events in the quantum world may not be bound by the same timeline that we experience in our macroscopic reality. As we combine the principles of entanglement and superposition, it becomes clear that time at the quantum level may not flow in a uniform manner. Just as entangled particles respond to each other instantaneously, so too might events in the quantum world be linked in ways we have yet to fully understand. The connection between these quantum phenomena and time invites us to reconsider the very nature of reality. Our understanding of time, once thought to be linear and unchanging, could in fact be far more complex, intricately woven into the workings of the universe in ways that are only just beginning to be understood. These revelations force scientists to rethink everything we thought we knew about time, suggesting that its true nature is far more intricate and mysterious than we could have ever imagined. One of the most striking implications of quantum mechanics is the uncertainty principle, which tells us that there is a limit to how precisely we can know certain pairs of properties about a particle, such as its position and momentum at the same time. To illustrate this, imagine trying to measure a tiny buzzing bee in a garden. The more accurately you pinpoint its location, the less certain you become about its speed or the direction in which it is flying. The very act of measuring one property disturbs the other. This principle is fundamental to our understanding of the quantum world, revealing that there are inherent limits to how much we can predict about the future. When applied to time, the uncertainty principle suggests that our ability to predict future events is inherently limited. Trying to forecast not just the position of a particle, but its future trajectory becomes a question of probabilities rather than certainties. The more we focus on one aspect of time, the less we can know about what lies ahead. In the world of quantum mechanics, this uncertainty is not a flaw, but a natural feature of how particles behave. It points to an underlying randomness in nature, suggesting that time itself may not be completely predictable at the smallest scales. However, this does not mean that the universe is purely chaotic. While individual events may be unpredictable, patterns and statistical laws still govern the behavior of particles over time. In other words, while we cannot precisely predict the exact course of a single event, we can understand the larger statistical tendencies that govern how things behave. The fundamental randomness of quantum mechanics, when applied to time, implies that what we perceive as an orderly, continuous flow may in fact be a far more fragmented and probabilistic process. At larger scales, we often think of time as a steady, unchanging force, like a river flowing from the past to the future, carrying everything along with it. This view of time, however, begins to break down when we enter the quantum realm. Here, particles do not behave like solid, stable objects, but rather exist in multiple states at once, shifting in and out of reality in ways that challenge our most basic assumptions. In some quantum theories, time is not seen as a continuous flow, but as a fragmented, piecemeal experience emerging from a deeper layer of reality where the normal rules of time do not apply. One hypothesis suggests that the quantum level, particles might be interconnected in such a way that they can communicate instantaneously across vast distances. This instantaneous connection would fundamentally alter how we think about time, making it behave less like a linear progression and more like a web, a network of interconnected events where cause and effect are no longer bound by the same rigid structure. In this view, time might not be a straight line, but something far more complex, a dynamic and fluid force that changes depending on the scale and context in which it is observed. As we continue to probe the quantum and cosmic realms, we are forced to confront the possibility that time, in all its complexity, is not what we have always assumed it to be. What we once thought to be immutable laws may be subject to deeper, more profound forces, waiting to be understood. In this exploration, the very nature of time itself could be one of the greatest puzzles that modern science seeks to solve. In recent years, a growing number of theories have begun to challenge our fundamental understanding of time, suggesting that it might not be the constant, unchanging force we've always assumed. Some scientists believe that time, in the context of quantum states, might even dissolve entirely, becoming an artifact of something deeper, a result of the complex, invisible interactions between subatomic particles. As researchers delve into these revolutionary ideas, they are not simply rethinking time in isolation. They are questioning the very fabric of reality itself, reshaping our understanding of the universe at the most fundamental level. What's particularly captivating about these ideas is the way they directly challenge our ingrained sense of cause and effect, the very backbone of how we interpret the world. In everyday life, we expect events to unfold in a linear, predictable sequence. One thing leads to another, one moment follows the next. However, in the strange world of quantum mechanics, this straightforward relationship begins to blur. In fact, on the most minuscule scales, the connection between cause and effect may not be as clear-cut as we believe. This suggests that at the level of quantum particles, time might behave in ways that are entirely foreign to our everyday experiences. Quantum mechanics unveils a reality where time is not fixed, not uniform, but fluid. In this peculiar realm, time doesn't pass continuously like a river flowing from one moment to the next. Instead, it behaves more like a series of snapshots, each representing a different slice of reality. Imagine flipping through a photo album, each page capturing a different moment in time. Quantum mechanics implies that the precise timing of events can vary depending on the observer's position, perspective, and speed. It's as if each observer is viewing time through their own lens, and this lens can alter the way they experience reality. This leads to a fascinating and paradoxical problem. The present moment, which seems so obvious to us in daily life, might not actually exist in a universal sense. Time in quantum mechanics doesn't follow a single, unchanging now. Instead, the present moment could be perceived differently by different observers, depending on their location and motion relative to one another. To visualize this, imagine a movie shot by multiple cameras, each capturing the scene from a different angle and pace. Every camera sees a different version of the now based on its own position and perspective. At the heart of quantum mechanics lies the strange concept of superposition, where particles do not exist in one fixed location or state until they are measured. Instead, they exist in a multitude of possibilities at once, almost like a cloud of probabilities rather than a definite point in space and time. This means that when we try to pinpoint the exact moment an event occurs, we run into a problem. Time loses its straightforward, continuous flow. The more we try to nail down the exact now, the more elusive it becomes, as particles move between possibilities. This uncertainty about time and space suggests that the idea of a universal synchronized moment of now becomes problematic. In a quantum universe, different observers might experience time in radically different ways. An event that appears simultaneous to one observer might be staggered for another. This leads us to a universe where time is relative, not just in the sense of being influenced by gravity, as Einstein proposed, but in a more profound, fundamental way. Here, the notion of a shared, synchronized existence, where every observer experiences the present moment in the same way, seems increasingly improbable. In quantum mechanics, experiments have produced results that push the boundaries of our understanding even further. One such experiment, the delayed choice experiment, shatters our intuition about cause and effect. In this thought-provoking experiment, scientists send particles, often photons, through a beam splitter, a device that divides the particles into two potential paths. But here's the twist. When researchers choose to measure the particles after they've already passed through the splitter, the particles appear to behave as if they had never been observed. It's as if their state is only determined by the act of measurement, despite the fact that the measurement was made after the particle had already decided on its path. This mind-bending outcome suggests that actions taken in the present may have an influence on the past, bending our classical understanding of time and causality. Another breathtaking aspect of quantum mechanics is the phenomenon of quantum entanglement. This phenomenon occurs when two particles become interconnected or entangled in such a way that the state of one particle instantaneously affects the state of the other, regardless of the distance between them. What's even more astonishing is that this interaction seems to happen faster than the speed of light, defying one of the fundamental principles of relativity. This instant connection suggests that time as we know it doesn't fully govern the universe's deepest interactions. Instead, there may be a deeper underlying reality where information transcends both the limitations of space and the conventional flow of time. These discoveries hint at a reality where the rules of time and space are far more fluid and complex than we ever imagined. If these theories are correct, then time itself might not be the immutable force we have always assumed. Instead, it could be a construct that, at its core, is deeply intertwined with the very nature of existence, shifting and warping in ways we are only beginning to understand. As our grasp of quantum mechanics deepens, the lines between past, present, and future may become increasingly blurred, revealing a universe that defies all our expectations. Time, as it turns out, might not be what we think it is at all. In the vast and intricate world of quantum mechanics, time emerges as a concept that defies our usual understanding. This field, which explores the behavior of subatomic particles, suggests that time might not flow in the linear, predictable way we've always assumed. One of the most mind-boggling phenomena in quantum physics is the concept of superposition, where particles can exist in multiple states at once. This strange behavior raises profound questions about the very nature of time itself. In experiments involving quantum superposition, particles do not simply exist as a single definite entity. Instead, they exist in a kind of indefinite state, simultaneously here and there, now and then. It is only when we observe or measure them that they collapse into one specific state, as though the act of measurement forces the particle to choose one of its possible realities. This collapse challenges our traditional notions of time and reality. Before measurement, a particle might be in a state that spans multiple possibilities, and only observation seems to decide the outcome. This idea, the notion that reality itself is fluid and indeterminate until observed, compels us to reconsider the very fabric of time. If particles can exist in multiple states, does that mean time, too, is not a fixed linear progression? Could it be that time behaves more like a set of probabilities, with moments that stretch and contract in a fluid, ever-changing dance? These quantum experiments suggest that the flow of time might not be as immutable as we once believed, opening the door to a new way of understanding the passage of time itself. String theory offers yet another fascinating way to think about time and its relationship with the universe. This theory proposes that the fundamental building blocks of the universe are not particles, as we once believed, but tiny, vibrating strings. These strings, microscopic and invisible, are thought to form the foundation of everything in existence. String theory offers a radically different perspective on the nature of time, suggesting that it is not a fixed, all-encompassing entity that exists independently of space and matter. Instead, string theory invites us to think of time as intricately woven into the very fabric of space itself. Time is not a backdrop against which events unfold, but rather a dimension that interacts with and is shaped by the spatial dimensions. This idea challenges our traditional view of time as a simple, linear flow from past to present to future. In a multidimensional universe, time could be experienced in entirely different ways depending on the dimensions in which one exists. This suggests that time, as we know it, may be more complex and less absolute than we have ever imagined. In the context of string theory, the past, present, and future may not even be as separate as they seem. If the universe is composed of interconnected strings vibrating in different modes, the clear-cut distinctions between past, present, and future might themselves be illusions. Rather than being a straightforward linear progression, time could be seen as more like a multi-layered musical chord, where each note vibrates at a different frequency, but all contribute to a cohesive whole. This concept invites us to reimagine time not as an unchanging sequence of events, but as a dynamic, complex structure influenced by the underlying principles of string theory. While string theory remains largely theoretical and is still being explored by scientists, its implications for our understanding of time are profound. It opens up the possibility that time itself is not a rigid, unchanging journey, but rather a deeply woven aspect of reality, shaped by the very strings that constitute the universe. This realization could completely transform our perception of existence, suggesting that the passage of time may be an illusion, a byproduct of deeper, unseen processes that govern the very nature of reality. The multiverse theory introduces yet another layer to our understanding of time, offering a vision of a universe far more expansive than we could have imagined. According to this theory, our universe is just one of potentially infinite parallel universes that coexist simultaneously. To picture this, imagine a vast library with an endless number of books, each one representing a different universe with its own set of physical laws, constants, and histories. In some of these universes, events may have unfolded differently, leading to entirely distinct realities, Within the framework of the multiverse, time no longer flows in a single, unidirectional stream. Instead, time becomes a branching, multifaceted entity, where every decision or event leads to the creation of new timelines. This process is akin to the growth of a tree, where each branch represents a different possible outcome or reality. Some of these branches may closely mirror our own timeline, while others might take entirely different paths, exploring alternate versions of reality. This view challenges our traditional understanding of causality and progression. If every decision creates a new timeline, then time is not a single, continuous flow, but rather a complex web of interconnected possibilities. In this new understanding, every moment is a node in a vast, branching structure, each one holding the potential for divergent realities. Time, then, is no longer a linear progression from past to present to future, but an intricate puzzle made up of countless scenarios and outcomes, each one subtly influenced by the choices and events that unfold in different versions of the multiverse. The concept of time travel also becomes much more complex when we consider the possibilities outlined by theories of relativity and quantum mechanics. Imagine time as a river flowing steadily forward, with each moment representing a point along its path. In Einstein's theory of relativity, however, this river is not fixed. Time can stretch and bend, influenced by massive objects like stars and black holes. These distortions in space and time, known as gravitational time dilation, can alter the flow of time itself. Scientists have explored the possibility of time travel by studying these distortions. One of the most famous models is the concept of a closed time-like curve, a path through space and time that loops back on itself, allowing for the potential of time travel to the past. While this idea is captivating, it introduces paradoxes, the most famous being the grandfather paradox. This thought experiment asks, what if someone were to travel back in time and prevent their grandfather from meeting their grandmother? The paradox arises because in this scenario, the time traveler could never have been born, creating a logical contradiction. Another intriguing possibility is that altering the past may not erase the original timeline, but create a new one, effectively splitting reality into multiple branches. In this model, a time traveler who changes something significant in the past might cause a new timeline to emerge, running parallel to the original one. While this offers a solution to some of the paradoxes associated with time travel, it raises other questions about identity, causality, and the nature of reality itself. Though we have not yet found a way to time travel, these theoretical models push the boundaries of our understanding and invite us to rethink the very nature of time and existence. They challenge our basic assumptions about the universe and provoke a deeper curiosity about the mysteries that still lie hidden within the fabric of space and time. Symmetry, a foundational concept in physics, also plays a crucial role in our understanding of time. At its core, symmetry represents balance, the idea that nature's laws are consistent and unchanged, whether viewed from the past or the future. This concept is essential when considering time symmetry, the idea that the laws of physics operate the same, regardless of whether we look at the past or the future. In a world of perfect symmetry, time would be perceived as smooth and continuous, with events unfolding in a predictable, reversible manner. However, when systems break symmetry, such as when a glass shatters, creating chaos and disorder, time appears to move in one direction, toward greater disorder. This phenomenon, known as entropy, creates the familiar flow of time we experience, where events seem to move only forward, never backward. But what if we could rewind the universe to a previous state? In an ideal, perfectly symmetrical world, everything would look the same, whether in the past or the future. But in reality, the universe tends to favor states of higher disorder, making the reversal of time feel unnatural and unlikely. Symmetry provides a framework for understanding why we perceive time as a one-way journey. It helps explain why the flow of time feels unidirectional, even though the equations governing motion are the same in both directions. This symmetry gives us a deeper insight into the nature of time and serves as a foundation for exploring the many mysteries that still surround it. At the heart of all these theories lies the concept of space-time, an interwoven fabric that links the three dimensions of space with the dimension of time. Rather than existing separately, space and time form a unified whole, shaping the very way we experience the universe. Think of space-time as a flexible sheet. When objects with mass like planets or stars are placed on it, they create indentations or curves. These curves influence how other objects move through space-time, including the flow of time itself. Albert Einstein's theory of relativity revolutionized our understanding of space-time, showing that the presence of mass distorts the fabric, creating what we perceive as gravity. This connection between mass and space-time means that the simple act of orbiting a planet or star is not just about the distance between objects, but also about the impact of time. Astronauts, for example, experience time differently from those on Earth due to the effects of gravity and the high speeds at which they travel. Their clocks tick at a slightly different rate than those on Earth, a phenomenon that has been experimentally confirmed through studies of high-speed satellites. This relationship between space, time, and gravity challenges our conventional understanding of time as a fixed, constant flow. Instead, it suggests that time is an intricate, malleable dimension, one that can be stretched, compressed, and altered by the forces of gravity and motion. The discovery of this connection marks a profound shift in our understanding of the universe, revealing a reality far more complex and interconnected than we could have ever imagined. Light, a fundamental messenger throughout the universe, embarks on an extraordinary journey across the vastness of space. It moves swiftly through the cosmic expanse, but it's not immune to the immense gravitational forces that shape the fabric of reality itself. When light encounters a massive object, like a planet or a star, it bends following the curvature of space-time. This phenomenon, known as gravitational lensing, dramatically reinforces our understanding of the intricate relationship between space and time. It illustrates how the very nature of the universe, its shape, structure, and behavior, are governed by this delicate interplay. Space and time are not just abstract concepts. They are deeply woven into the fabric of everything we observe. From the orbits of distant planets to the way light bends around galaxies, this connection influences all matter, all energy, and all motion. The way we understand time, an unyielding, continuous flow that moves from past to present to future, has shaped not just science but also our everyday existence. Time feels like a constant force, guiding our lives, influencing our decisions, and marking every second. But what if time is not what we think it is? If we start to perceive time as an illusion, a mere construct, we're invited to step away from the traditional understanding of it as an unchanging, linear sequence. Our conventional view sees time as a rigid schedule, broken into hours, minutes, and seconds, distinctions that dictate when we work, play, eat, sleep, and interact. But by recognizing time as something fluid, we open ourselves to the possibility of a more flexible existence, one that's no longer bound by the constraints of ticking clocks and strict routines. Imagine this: your day no longer divided into the neat boxes of work, leisure, and rest. The boundaries that separate each activity could blur, and suddenly there would be less pressure to fit everything into neatly defined slots. Work might not need to be done by a specific time, and leisure could be experienced without the nagging thought of what comes next. Rest could become a deeper experience, freed from the idea that it is a waste of precious time. The rigid structure of time's passing could lose its grip, making room for more spontaneous, yet meaningful experiences. This new understanding could also fundamentally shift how we experience relationships. Too often we rush through moments with others, glancing at the clock, counting down the minutes until the next meeting or commitment. But if time weren't an immutable force, if it were just an idea we've agreed upon, then maybe we would spend more time present with each other, savoring conversations, listening intently, and creating bonds without the anxiety of rushing toward the next event. What if, instead of thinking about time as running out, we allowed ourselves to feel the richness of the moment, to truly engage with the people around us? This shift in perspective toward a more fluid view of time could revolutionize how we live. It would free us from the tyranny of a future we're constantly chasing. Instead of always striving toward future milestones, we could discover fulfillment in the present. Satisfaction could be found in being right here, right now, instead of in what comes next. As we question time's true nature, we might redefine not only our personal priorities, but also the way societies function. The constant drive for productivity, for measurable success, could be replaced by a focus on quality of life, on living more holistically in the present moment. Happiness could stop being tied to future achievements and start being found in the simplicity of existence. The cosmic perspective we gain by studying the vastness of the universe has the potential to change how we approach not just our personal lives, but our collective health and well-being. The more we learn about the universe, the more we realize just how small and interconnected we are. This awareness doesn't just shift our thinking about space, it also has profound implications for fields like medicine and psychology. For example, studying how the human body responds to microgravity, such as during space missions, has led to breakthroughs in understanding muscle atrophy and bone density loss. These insights have the potential to revolutionize treatment for aging populations, as well as for patients who are bedridden or immobile here on Earth. The health challenges posed by space travel might offer new ways to combat the ailments that afflict us on Earth. Similarly, the technology developed to address the extreme conditions of space, such as reliable medical equipment and life-saving innovations, could be applied to improve emergency care, surgical procedures, and diagnostic capabilities back home. In psychology, the lessons learned from the isolation experienced by astronauts orbiting the Earth offer invaluable insights into stress management and coping strategies. The mental toll of long-duration space missions has led to the development of techniques that can help those dealing with isolation, anxiety, and loneliness in their own lives. Furthermore, by studying how humans react to extreme environments, psychologists can uncover new ways to build resilience, both in space and on Earth. These findings could lead to better therapeutic approaches, improving the mental health of people everywhere. On a broader scale, space exploration teaches us about fear and resilience, two concepts that are central to the human experience. Confronting the unknown in space offers a mirror to the way we face challenges in our daily lives. The lessons learned from astronauts who endure the physical and psychological strain of space travel could be applied to help individuals navigate personal difficulties, from fear of the future to anxiety over the unknown. In contemplating time's true nature, we also open the door to profound creative possibilities. When we view time as a rigid and fixed force, it often restricts how we think, creating boundaries that stifle imagination. But if we let go of this notion, if we see time as fluid, as something malleable, the floodgates of creativity could swing wide open. Think of a world where past, present, and future aren't rigidly separated, but interwoven, a continuous, fluid spectrum. This would invite a new kind of creativity, one that draws not only from current experiences, but also from memories and future possibilities. For artists, scientists, and innovators, this perspective would blur the lines between what has been done and what could be, encouraging experimentation and merging ideas from different points in time. The free flow of time might inspire fresh, unprecedented concepts, where earlier visions are revisited and reimagined, reshaping our world in unexpected ways. Furthermore, if we let go of the pressure imposed by time, we might allow ourselves the freedom to explore, fail, and learn. If time weren't seen as a limited resource, we might be less afraid to take risks, experiment, and try new ideas. Each failure would no longer be seen as a setback, but as a necessary step in the journey of infinite possibilities. This would unleash the full potential of human creativity, fostering progress in ways we can barely imagine. The implications of a deeper understanding of time go beyond creativity. They could redefine the very nature of technological advancement. Time, in its most fundamental form, governs everything in the universe, from communication to travel, from the speed of light to the flow of information. If scientists can unravel more about time's behavior, such as how time moves differently under various conditions, a concept known as time dilation, it could lead to breakthroughs in everything from precision timekeeping to synchronized communication systems. Time's relationship with gravity could also lead to incredible innovations. Imagine a future where transportation systems are designed to harness gravitational forces, allowing for faster or more energy-efficient travel. While these concepts are still theoretical, The research we conduct today could lay the groundwork for unimaginable technological advancements tomorrow. Though time manipulation may seem like the realm of science fiction, the study of time's true nature may eventually inspire real-world technologies that change how we live, work, and interact with the world around us. As we continue to explore the mysteries of the universe, we unlock not only new knowledge of the cosmos, but also new possibilities for how we can reshape life on Earth. And with that, the future may hold innovations beyond our wildest dreams, each one building upon the fluidity and malleability of time itself. The exploration of time is a pursuit that transcends the boundaries of scientific inquiry, delving into the very essence of existence. At the forefront of this quest is the notion that understanding time more deeply could have far-reaching implications, not just for the theoretical realm of physics, but also for the practical and transformative fields of technology, biology, and even the future of human health. As we unravel the mysteries of time, the potential for advancements in quantum computing is enormous. Quantum technologies already operate on the peculiar behaviors of particles, where the fabric of space and time bends in ways that defy our classical understanding. Time's elusive properties could inspire new algorithms and processes within quantum computing, unlocking the potential for faster, more powerful computers. These innovations could revolutionize fields like artificial intelligence, data processing, and even computational neuroscience, but enabling us to solve problems that were once unimaginable. Beyond the realm of computation, a deeper understanding of time could profoundly reshape the way we approach biology, particularly in how we perceive human development and aging. With time at the core of biological processes, from cell replication to neural activity, exploring its role could open the door to revolutionary advancements in medicine. Imagine treatment protocols that adapt not only to the biological stage of an individual, but also to the underlying temporal dynamics at play within their cells. In the long term, this could significantly alter how we approach aging, enabling breakthroughs in longevity and more effective interventions for age-related diseases. Essentially, by decoding the complexities of time, we may not only advance existing technologies, but also open entirely new frontiers. These frontiers, previously limited by our current understanding, could pave the way for novel solutions in medicine, energy, and beyond. However, every major advancement depends on how effectively we translate complex ideas into practical, accessible tools that improve the quality of our daily lives. This is where the importance of interdisciplinary research becomes apparent, where the convergence of physics, biology, and engineering will determine how deeply these theoretical concepts can be integrated into society. The realm of space exploration has also demonstrated how understanding extreme conditions in space can directly influence sustainable practices on Earth. As we reach further into the cosmos, the technologies that support space missions provide us with a treasure trove of innovative solutions for resource management, energy generation, and waste recycling. In the vast, resource-constrained environment of space, every ounce of material is valuable and every resource is tightly conserved. Technologies that allow spacecraft to recycle water and oxygen efficiently could find their way into industries on Earth, reducing waste and conserving critical resources. Closed-loop systems, which manage everything from water to air, could become commonplace in environments like cities or remote communities, contributing to a sustainable future. Moreover, space exploration offers a unique vantage point for the development of renewable energy solutions. The push to power spacecraft using solar energy, for example, might serve as a catalyst for cleaner, greener energy solutions on Earth. This could help accelerate the transition away from fossil fuels, not just in space, but also in industries across the globe. Economically, the burgeoning space industry also promises to create entirely new markets, job opportunities, and technological ecosystems. Investing in space technologies doesn't just improve communication infrastructure or enhance medical tools, it has a ripple effect, boosting industries like material science, telecommunications, and advanced manufacturing. In turn, this economic boom can stimulate job creation across sectors, ushering in a new era of innovation. Furthermore, understanding the environmental and economic dynamics of other planets and ecosystems beyond Earth can offer critical insights into climate change. By studying the processes that govern planets and their atmospheres, scientists can uncover patterns and predict how our own planet's climate may shift. This comparative approach helps us better understand the complexity of Earth's ecosystems, potentially leading to more effective environmental policies and mitigation strategies. When it comes to time itself, the debate over whether it is an illusion or a concrete dimension of reality has been a long-standing issue within both the scientific and philosophical communities. On one side, physicists argue for the reality of time, particularly through the lens of Albert Einstein's theory of relativity. Relativity revolutionized our understanding of space and time, showing that they are intricately linked in a four-dimensional continuum known as space-time. According to this theory, time behaves in a measurable and consistent way, but its passage is relative to the observer's speed and position. Time moves differently for someone traveling at near light speeds compared to someone who is stationary. This difference, known as time dilation, offers compelling evidence that time is a real and fundamental dimension of our universe, rather than a mere illusion. Further support for the reality of time comes from the second law of thermodynamics, which states that in any closed system, entropy, or disorder, tends to increase over time. This law suggests that time moves in one direction, often referred to as the arrow of time. We experience this progression daily. Ice melts, objects break, and aging occurs. This phenomenon consistently aligns with our understanding of time as a tangible, measurable force. Neuroscience also contributes to the ongoing debate, examining how humans perceive the passage of time. The brain processes experiences and memories in ways that create our subjective sense of time. While our internal clock may vary from one person to another, the external, physical passage of time provides a framework that grounds our cognitive perceptions. The interplay between these subjective and objective realities reinforces the idea that time, though perceived differently by individuals, is anchored by external, measurable forces. However, not all scientists agree that time is a tangible, independent dimension. Some propose that time may not exist at all, but is rather an emergent quality, a consequence of more fundamental physical laws yet to be fully understood. The quantum world, with its bizarre phenomena like entanglement, challenges our linear view of time. In entanglement, particles affect one another instantaneously, regardless of distance. This challenges the concept of time as a strictly linear progression, and has led some physicists to speculate that time might not be a fundamental part of reality, but rather a construct that emerges from deeper quantum phenomena. The advancements in technology have provided further insights into the nature of time. Clocks on satellites, for example, tick at slightly different rates than those on Earth due to differences in gravitational pull, a phenomenon known as gravitational time dilation. This difference is not just an interesting curiosity, it has practical applications, such as in the Global Positioning System, GPS, where precise time measurements are critical for accurate navigation. These experiments and technological breakthroughs show that time is not simply a constant or a steady stream. Instead, it is a dynamic, complex feature of the universe, influenced by factors like gravity, speed, and even the strange behavior of particles at the quantum level. As research continues, our understanding of time will undoubtedly evolve, offering new insights into both the universe and our place within it. Throughout history, experiments and theories have radically altered our conception of time, pushing the boundaries of both science and philosophy. Einstein's theory of relativity was one of the first to break the traditional Newtonian view of time as a constant. His work suggested that time, far from being a uniform linear progression, is a flexible dimension that can stretch and shrink depending on one's speed and gravitational field. This understanding was supported by thought experiments and real-world observations, such as the slowing of time for objects traveling at high speeds. Further challenges to our perception of time emerged through particle physics. In high-speed experiments, scientists observed particles known as muons, which exist longer when traveling near the speed of light than when at rest. This real-world evidence of time dilation provided further validation for the relativity theory, showing that time can be stretched and compressed depending on motion. In the realm of quantum mechanics, the study of entangled particles has raised even more profound questions about the nature of time. In these experiments, two particles can be entangled, meaning that the state of one particle affects the state of another instantaneously, regardless of the distance between them. This behavior, which seems to defy the conventional understanding of time as flowing in one direction, challenges the way we think about cause and effect, and has led physicists to explore the possibility that time, as we know it, could be an emergent property rather than a fundamental force. These revolutionary experiments have fundamentally altered our perception of time. Time is no longer a simple, unchanging measure. Instead, it is a dynamic, multifaceted phenomenon, one that is deeply intertwined with the structure of space, motion, and even the very fabric of reality itself. As we continue to explore and understand these complexities, we are forced to reconsider not only how we measure time, but also how we experience it, live within it, and ultimately, how it shapes our universe. Time has always been a subject of fascination, not just for scientists and philosophers, but for anyone who has ever paused to think about it. Its implications stretch far beyond theoretical discussions. They echo throughout the very foundations of how we understand our world, especially in the realm of physics. Theories such as Einstein's theory of relativity have revolutionized our grasp of time, presenting it not as an immutable constant, but as something much more flexible, even malleable. According to relativity, time is not fixed. It changes based on factors like speed and gravity. These discoveries have ignited crucial debates about the nature of time itself, whether it's a physical entity that exists independently of us, or just a construct that helps us make sense of our experiences. As researchers continue to probe the depths of time, their contrasting theories often lead to friction within the scientific community. The differences between these views, however, are not limited to the academic sphere. They reverberate throughout the public domain. Ordinary people, captivated by the profound questions regarding the very fabric of reality, start to question: is time real? Is it something we perceive through our senses, or does it exist as an objective entity outside of us? These are not mere musings. They challenge the very essence of human experience and how we interact with the world around us. The debates on time become an ongoing, evolving exploration, one that captivates minds across disciplines and cultures. Unconventional or fringe theories, though often dismissed by mainstream scientists, are often the sparks of revolutionary thinking. These ideas push the boundaries of accepted knowledge, challenging the very foundation of what is believed to be true. The emergence of such theories provokes curiosity, igniting debates that ripple through the scientific community and beyond. While many fringe theories might initially seem implausible, they have been known to drive the exploration of new hypotheses, which, in time, may be tested, refined, and integrated into the broader body of scientific knowledge. The very act of questioning leads to the discovery of new pathways and, on occasion, to serendipitous revelations that can alter our understanding of the universe. Some of the most groundbreaking scientific advancements have come from ideas that were once considered outlandish or even nonsensical. What was dismissed as fringe speculation in one era can, in another, become the foundation for a new scientific paradigm. These ideas are not just abstract concepts. They often catch the public's attention, generating widespread interest in the phenomena they seek to explain. This, in turn, encourages greater public engagement with science, fostering collaboration among researchers from diverse fields, and helping to create an environment where innovation thrives. Ultimately, the presence of fringe theories in scientific discourse serves as a reminder that true progress often requires us to entertain ideas that may seem unorthodox or improbable at first glance. On a personal level, time's significance often becomes most apparent during transformative moments in life. Consider an individual who is diagnosed with a life-threatening illness. In an instant, their perception of time can change from something to be taken for granted into a precious, fleeting resource. Each passing moment, once a blur of routine, becomes imbued with urgency and meaning. The person may find themselves focusing more on what truly matters: relationships, passions, dreams long deferred. There is a marked shift in priorities. Spontaneity may replace rigidity as the individual embraces life's most important experiences, This contrast between taking time for granted and suddenly realizing its fragility often leads to a profound reevaluation of one's purpose and actions. Similarly, the birth of a child can deeply alter a person's perception of time. The endless waiting transforms into a whirlwind of fleeting moments, each milestone seeming to arrive with lightning speed, and yet every step of growth feels simultaneously slow and inevitable. A parent may find themselves savoring small moments they once overlooked, acutely aware of how quickly time passes as they watch their child grow. These personal stories of transformation, whether brought about by illness, parenthood, or another life-altering experience, remind us that time is not just a measure of our existence. It is deeply intertwined with the memories and relationships that shape our lives. These profound shifts in the perception of time can also arise from cultural exposure. People who travel widely, immersing themselves in diverse cultures, often find that their understanding of time evolves. In some cultures, time is fluid, a concept that does not dictate rigid schedules but instead flows organically with life. These experiences can lead to a rethinking of priorities, where the emphasis shifts from productivity to connection. When they return home, these travelers may find themselves placing more value on relationships and less on the clock. Time is no longer just something to be managed or spent, but something to be appreciated for its role in creating moments of connection and meaning. Time is often described as an illusion, a concept that sparks passionate debate, particularly when personal experiences are involved. For some, time feels elastic. Moments of joy or fear stretch into eternity, while mundane hours fly by unnoticed. These subjective experiences challenge the idea that time is something universally constant. Could it be, as some argue, that time is more of a mental construct, a product of our perception rather than an absolute reality? However, others maintain that time is objective, governed by universal laws. Events in nature, like the changing of seasons or the growth of a plant, follow a predictable rhythm, one that can be measured and observed. This regularity supports the idea that time exists independently of our perception as a continuous and measurable entity. The debate becomes even more complex when we consider near-death experiences, in which individuals often report a sensation of timelessness. During these moments, life events may appear to occur simultaneously, as though the linear flow of time has ceased to exist. Such accounts seem to transcend the everyday understanding of time, suggesting that our consciousness may operate outside the boundaries of the conventional timeline. While these personal accounts of timelessness may seem to contradict the scientific view of time, they add a layer of richness to the debate. They highlight the complexity of time, suggesting that it is not only a measurable quantity, but also a deeply personal experience. The interplay between the objective external reality of time and the objective internal experience of it is a central theme in the ongoing exploration of this concept. Practices like mindfulness and meditation can profoundly alter how we experience the passage of time. When people engage in these practices, they often find themselves in a state of heightened awareness. This deep focus can make time seem to stretch as individuals become fully absorbed in the present moment. Compare this to the experience of a busy day, when hours seem to slip by unnoticed as the mind jumps from task to task. Mindfulness pulls the mind back to the present, fostering a richer, more expansive experience of time. Neuroscientific research suggests that regular meditation can also influence the brain's perception of time, improving connectivity in areas associated with awareness, memory, and emotion. This shift in awareness can lead to a more profound sense of presence, allowing individuals to develop a healthier relationship with time, one that is less focused on the future and more on the now. The human experience of time is often most acutely felt during moments of significant change, whether that be loss, growth, or wonder. For example, witnessing a loved one age or facing a difficult goodbye can create a heightened sense of time's passage. Similarly, awe-inspiring events, like watching a sunset or gazing at the stars, can evoke a sense of timelessness, where the boundaries of the moment dissolve. In these instances, time seems to stretch or contract, making us more acutely aware of the fleeting nature of life. Creative expressions, whether through art, literature, or music, often explore these very themes, Novels, for example, may unfold in a non-linear fashion, illustrating how time is not just a straight path, but a series of intersecting memories and moments. Artists use symbols like hourglasses, clocks, or sunsets to represent time's passage, prompting reflection on its inevitability. Poetry, with its powerful metaphors and condensed imagery, often captures the feeling of time slipping away, reminding us of how quickly life passes and urging us to reflect on the moments that define our existence. As we engage with these creative works, we are reminded that time is not merely a linear progression. It is a complex, multi-dimensional experience, one that we perceive through our memories, emotions, and actions. Art and literature invite us to consider time not as something to be managed, but as something to be felt, to be understood in its full emotional and existential depth. Through these lenses, we come to appreciate time as both a measure of our lives and a powerful force that shapes our identities, relationships, and experiences. If society were to shift its understanding of time from a rigid, objective framework to something more fluid, something more like an illusion, it could lead to profound changes in how we live. If time were no longer seen as something to be controlled, but rather something to be experienced, our approach to daily life might become more flexible, more focused on the present moment. This new perspective might encourage deeper, more meaningful interactions, a prioritization of experiences over schedules, and a greater appreciation for the moments that make life meaningful. Such a societal shift could also transform the workplace. Imagine a world where businesses valued productivity over hours spent in the office, where employees were empowered to explore ideas and innovate without the pressure of strict deadlines. This could lead to increased creativity and collaboration, as people are freed from the constraints of a traditional time-based workday. In such a world, time would no longer be something that dictates our actions, but something that flows with the natural rhythms of our lives, guiding us to make the most of each fleeting moment. In the end, whether we view time as an illusion or as a fundamental truth, it undeniably shapes our lives in profound ways. From the grand questions of physics to the deeply personal experiences of daily existence, time remains a mystery, one that invites us to question, reflect, and ultimately embrace the moments that define who we are. The notion of time, as we traditionally perceive it, has long been embedded in the rhythm of human existence, an unyielding progression from past to present and onward into the future. But what if everything we know about time is only a small fragment of a much larger, more intricate truth? Imagine if the way we think about time, the relentless ticking of the clock, was not an absolute reality, but instead a constructed perception. This shift in understanding, a transformation in how we view the nature of time, could have profound implications for the way we live, interact, and even govern ourselves. Furthermore, such a transformation in our comprehension of time could foster a more mindful, reflective approach to life. In a world where we are often anxious about the future and burdened by regrets over the past, an emphasis on the present could be the key to reducing stress and cultivating a deeper sense of well-being. If we learn to ground ourselves in the now, it might help us release the weight of future worries and past mistakes. This shift could encourage individuals to develop habits of mindfulness, reflective practices, and personal growth, which, over time, might lead to a more compassionate society, one that places greater value on harmony and empathy rather than competition and individual success. As we begin to see time differently, it could spark a cultural revolution, redefining how we view achievement and success. Our focus could shift away from rigid schedules and measurable accomplishments and towards meaningful experiences and deep relationships. The current obsession with productivity, with hitting milestones tied to set timelines, might fade as we embrace a more fluid approach to living, one that prioritizes connection over competition. Time, viewed as an illusion or a flexible concept, would empower individuals to live more authentically and creatively. Such a radical rethinking of time would not only change our personal lives, but could reverberate through the very foundations of society. In particular, the world of education stands to benefit immensely from this shift. Education as it currently exists is built around a strict timetable, seasons of learning, semester after semester, each with its own deadlines and requirements. But what if time in education could be expanded or contracted based on individual needs? What if the rigid schedules that define the academic year were replaced with a more flexible model that emphasized personalized, self-paced learning? Imagine students advancing at their own speed, learning without the pressure of exams, without the stress of ticking clocks, and without the sense of having to rush through concepts they don't fully grasp. This would allow for a deeper understanding of material, more time spent exploring topics of genuine interest, and less pressure to conform to arbitrary schedules. A redefined sense of time could lead to classrooms that are more dynamic, interactive, and immersive. Education could become an organic experience, blending different learning methods, subject areas, and timelines into one interconnected whole. For subjects like science, where deep, investigative learning is essential, this could open up new pathways for students to engage with their studies in ways that are both personal and profound. Additionally, this shift in the perception of time could profoundly impact collaborative learning. Students working in groups with varied perceptions of time could approach projects and ideas in novel, creative ways. The group could navigate through problems and explore solutions at their own pace, cultivating an environment where divergent thinking is not just encouraged, but necessary. The end result would be a generation of learners not bound by arbitrary limits, but instead empowered to explore, create, and collaborate in ways that better reflect the realities of the world they are inheriting. If education were to embrace a more fluid and personalized approach to time, it could also reorient itself towards the concept of mastery rather than memorization. Instead of merely focusing on covering a set syllabus within a given time frame, the emphasis could be on deep, meaningful learning experiences, learning that is centered around growth, curiosity, and personal development. Teachers would no longer be bound by a set curriculum or a rigid timetable, but instead would become facilitators of exploration, helping students journey through topics and concepts at their own pace and depth. Looking beyond our own planet, we can see that time has profound implications for how we understand both our history and the future. Throughout history, we have often perceived events as isolated, linear moments that happen because of human choice. We have viewed ourselves as the masters of time, the directors of events. But when we zoom out, when we take a step back and view our history from the cosmic perspective, we realize that we are but a speck in an expansive, interconnected universe. Our story, and indeed the story of time itself, is far more entangled with the broader workings of the cosmos than we ever realized. Climate change, natural disasters, and even the motion of celestial bodies have all played significant roles in shaping human civilization. These events, although often beyond our immediate control, continue to affect us in profound ways. If we begin to view human history as part of a much larger cosmic narrative, we might begin to think more holistically, not just about the world we inhabit, but about how our actions ripple out across the universe. Understanding that we are part of a larger, ever-evolving story might inspire us to adopt more sustainable practices, care more deeply for the environment, and consider the long-term consequences of our choices. Instead of seeing time as an individual, isolated trajectory, we could start to view our actions as interwoven threads in the fabric of the universe, each choice a step towards a more harmonious and responsible future. This cosmic perspective also transforms how we might approach our future planning. Rather than viewing time as a straight line, one that we are meant to march along, we could adopt a more interconnected, sustainable approach. We would begin to think not just about our immediate needs and desires, but about how we impact the delicate systems that sustain life on Earth. Our responsibility to the planet and to future generations might become clearer, and our vision for the future might shift from one of limitless growth to one of balance, care, and stewardship. But these shifts in understanding time are not just confined to the way we live on Earth. As we venture beyond our home planet, we enter a new frontier where time, law, and governance will intersect in complex and unprecedented ways. Space exploration, once the realm of science fiction, is becoming an ever-growing reality. As humanity stretches its reach beyond Earth, we must consider the implications of our actions on a cosmic scale. One of the most pressing concerns is the issue of ownership. Who owns the Moon, Mars, or asteroids? Who has the right to claim resources from these celestial bodies, and under what circumstances? Currently, international treaties dictate that space is considered a common heritage of mankind, meaning no single nation can claim sovereignty over celestial bodies. This notion, although noble in its intent, has raised questions about how we manage the potential resources that space may offer. The prospect of mining asteroids for valuable minerals or harvesting water from the moon or Mars could have vast implications for humanity, but it also presents legal, environmental, and ethical dilemmas. As private companies begin to play an increasing role in space exploration, the complexities of governance become even more pronounced. Who is responsible when things go wrong in space? Is it the company, the nation, or the astronauts themselves? The legal framework around space travel and exploration will need to evolve to keep pace with technological advancements and the growing involvement of private enterprises. Furthermore, space exploration also raises concerns about environmental sustainability, with space debris becoming an increasingly pressing issue. Space junk left behind by satellites and spacecraft poses risks to future missions and the delicate ecosystem of outer space. New regulations will be necessary to mitigate these risks and ensure that space remains a safe and viable environment for exploration and discovery. Perhaps most thought-provoking of all, the idea of colonizing other planets will require entirely new legal systems. As humanity takes steps toward establishing permanent settlements on Mars or beyond, the question of governance, who makes the laws, who enforces them, and who holds citizenship in these distant colonies, will become critical. These new off-world societies may necessitate entirely new ways of thinking about human rights, citizenship, and international cooperation. How will we manage resources, ensure fair treatment, and uphold basic human dignity in environments far from Earth? The militarization of space is another looming issue. As nations develop space-based defense technologies, the potential for conflict in space grows. How will we avoid turning space, the final frontier, into a battleground? Will international treaties be enough to maintain peace, or will new governance structures need to emerge to ensure that space remains a domain for peaceful cooperation and scientific discovery? In the end, as humanity stretches its boundaries into the cosmos, the need for thoughtful, ethical, and collaborative governance will become more pressing. Our legal and governmental frameworks must evolve to keep pace with our expanding reach, ensuring that space remains a place for exploration, discovery, and shared responsibility. Finally, cultural narratives surrounding time often shape how we perceive our lives, our destinies, and the very fabric of reality itself. In many societies, time is seen as a linear journey, a series of events moving inexorably forward from the past through the present and into the future. In this framework, destiny is often viewed as a predetermined path that guides individuals along their lives. This notion of fate, while comforting to some, can also feel restrictive, an unwelcome force that directs one's life in a direction that may not align with personal desires or choices. Yet, the illusion of time offers a different perspective. Time, from a scientific standpoint, is not as fixed as we believe it to be. It is a malleable, fluid construct, one that unfolds in a way that is deeply influenced by the choices we make, the speed at which we travel, and the gravity of the environments in which we exist. Through groundbreaking experiments, such as those with atomic clocks, scientists have demonstrated that time is not a universal constant, but can pass at different rates depending on speed and gravity. This phenomenon, known as time dilation, shows that time is not linear. It can stretch, compress, and flow differently based on the observer's relative position in space-time. This revelation opens up profound new questions about our perception of reality, of fate, and of free will. Is the future set in stone, or is it a field of infinite possibilities, shaped by the choices we make? The tension between the concepts of fate and free will, destiny and choice, is a central theme in many cultural narratives, and as our understanding of time continues to evolve, so too will our perception of our place within the universe. In conclusion, as we explore the mysteries of time, we not only deepen our understanding of the cosmos, but also of ourselves. Time is more than just a ticking clock. It is a doorway to new possibilities, new ways of living, learning, and understanding our world. Through these revelations, we are invited to step into a new era, one where we embrace the fluidity of time and all the opportunities it presents for personal, societal, and cosmic transformation. In the vast expanse of the universe, where the nature of time once seemed immutable, recent breakthroughs in science and technology have begun to reveal a far more fluid and dynamic conception of time, one that reshapes how we understand not only the universe itself, but also the very fabric of reality. At the heart of these revelations lies the study of gravitational waves. These ripples, generated by massive cosmic events, such as black hole mergers or the collision of neutron stars, offer a profound insight into the structure of space-time. When these waves travel through the universe, they stretch and compress space, creating tiny distortions that can be detected by highly sensitive instruments. By observing these gravitational waves, scientists are able to probe the intricate relationship between time and space, gaining a deeper understanding of how the two interact in the ever-changing, dynamic fabric of the cosmos. What is particularly striking about these discoveries is how they challenge our traditional understanding of time as a fixed, unyielding timeline. Instead, these observations suggest that time behaves more like a fluid tapestry, intricately woven with the curvature of space and the energy that permeates the universe. Furthermore, experiments on quantum entanglement have expanded our understanding of time in even more unexpected ways. Quantum mechanics, the branch of physics that deals with the behavior of the smallest particles in the universe, has long suggested that particles can be entangled, meaning their properties are instantaneously linked, no matter the distance between them. In some cases, entangled particles appear to communicate faster than the speed of light, raising profound questions about the nature of causality, the principle that cause precedes effect. This phenomenon challenges our conventional understanding of time, which is typically seen as a linear progression. In quantum systems, however, it seems that time may not flow uniformly for all particles, suggesting that time might be far more elastic than we have ever imagined. These quantum experiments, together with discoveries from the study of gravitational waves, paint a picture of time as a multifaceted, complex dimension that is deeply intertwined with the very structure of reality itself. Time is not an isolated, rigid concept, but a flexible and interconnected element that responds to changes in space, energy, and gravity. This perspective continuously reshapes our understanding of the universe, pushing us to rethink not just the physics of the cosmos, but the very essence of existence. Technological advancements have played a crucial role in deepening our understanding of time. In the past, time was often seen as a constant, an ever-ticking clock that measured the flow of life in unchanging intervals. But as technology has evolved, so too has our ability to explore the way time behaves under different conditions. One of the most influential tools in this exploration is the atomic clock. These highly precise instruments measure time based on the vibrations of atoms, which are extraordinarily consistent. By comparing atomic clocks placed in different locations, on Earth's surface, in orbit, or even in space, researchers have been able to detect variations in time due to changes in gravity and speed. This is where Einstein's theory of relativity comes into play. Einstein's theory suggests that time is not a universal constant. It can slow down or speed up depending on the strength of the gravitational field and the relative speed of an observer. For instance, time runs slightly slower on the surface of Earth, where gravity is stronger, than it does for a satellite orbiting far above the planet. This phenomenon has been directly measured, confirming that time is far more malleable than we once believed. Similarly, advances in GPS technology have provided a practical example of relativity in action. GPS satellites orbiting Earth experience slightly different gravitational forces and velocities than we do on the ground. If these differences weren't taken into account, GPS systems would quickly produce inaccurate location readings, demonstrating just how profoundly time is affected by physical conditions. Moreover, experiments in particle accelerators have further shown how time behaves in extreme environments. Particle accelerators, enormous machines that speed up tiny particles to nearly the speed of light, provide scientists with the opportunity to study time under extreme conditions. As particles approach the speed of light, their mass increases and time appears to slow down relative to stationary observers. This effect, known as time dilation, directly confirms Einstein's predictions about the relationship between time, speed, and gravity. High-energy collisions and accelerators also allow researchers to observe how particles decay over time, providing valuable insights into the evolution of the universe from the Big Bang to the present day. These discoveries underscore a fundamental truth about the nature of time. It is not a constant, ticking clock, but a variable, dynamic entity that stretches and contracts depending on speed, gravity, and the forces at play. The more we probe the universe's deepest mysteries, the more we uncover the rich, complex layers of time, revealing a landscape that is anything but linear. The study of particle accelerators, for example, not only brings us closer to understanding the building blocks of matter, but also forces us to confront the very nature of existence itself. How does time operate in the smallest corners of the universe? How does it shape the events of the cosmos on the grandest scale? Astronomical observations, too, have drastically altered our understanding of time. For centuries, time was thought to be a simple progression, an unbroken line where past events led directly to the present and the future unfolded naturally. But as our ability to observe the universe has expanded, we have encountered phenomena that complicate this view. When we observe distant stars, galaxies, or cosmic events, we are not seeing them as they are in the present moment. Instead, we are looking at light that has traveled for millions or even billions of years to reach us. In essence, we are witnessing the past, seeing the universe as it once was, rather than as it is right now. This realization not only challenges the idea of time as a simple flow, but also suggests that our present moment is deeply connected to the past, a past that we can still observe, albeit in a distant and fragmented form. Additionally, astronomical observations of cosmic events like supernovae or the expansion of the universe further complicate our understanding of time. The expansion of the universe suggests that time itself is not a fixed, static phenomenon, but a constantly evolving process. Galaxies are moving away from each other, and the universe is stretching, creating a timeline that is not straightforward, but dynamic, ever-changing, and influenced by cosmic forces. The idea of time as an unbroken line becomes even more uncertain in the light of these discoveries. The fate of the universe, it seems, is tied to a more intricate, complex timeline than we had ever imagined. The theories of relativity, which revolutionized our understanding of space, time, and gravity, have further contributed to this more complex view of time. In strong gravitational fields or at high speeds, time slows down or speeds up. For instance, near a black hole, where gravity is extraordinarily intense, time moves far more slowly than it does far away from the black hole's pull. This idea that time can stretch, compress, or bend under different conditions adds yet another layer of complexity to our conception of time. All of these observations and theories point to the fact that time is not a simple linear flow, but a rich, multifaceted dimension that is deeply interconnected with the fabric of space and energy. Time, as we have come to understand, is not a fixed, unchanging force, but a dynamic, fluid element of the universe, one that is constantly shaped and reshaped by the forces of gravity, speed, and the very structure of the cosmos. In recent years, artificial intelligence, AI, has opened up new avenues for exploring the nature of time. AI has allowed scientists to analyze vast amounts of astronomical data with incredible speed and efficiency. Traditional methods of studying the movement of celestial bodies involved manually applying complex mathematical models to predict their future trajectories. AI, however, can sift through enormous data sets and identify patterns far more quickly than human scientists. This has led to groundbreaking new insights into the role that time plays in the formation and movement of galaxies, suggesting that AI may one day revolutionize our understanding of time itself. As our technological capabilities continue to advance, our understanding of time continues to deepen. What was once seen as a constant, unyielding tick of the clock has evolved into a complex, multidimensional landscape, one that challenges our assumptions, stretches our imaginations, and invites us to reconsider everything we thought we knew about the universe. The exploration of time, both in the realms of science and technology, is far from over. Each new discovery brings us closer to unraveling the mysteries of existence itself, revealing just how intricately time is woven into the fabric of the cosmos. Moreover, researchers have harnessed the power of artificial intelligence, AI, to probe the enigmatic nature of time at the quantum level. At this microscopic scale, particles behave in ways that seem utterly unpredictable. Their interactions can challenge our conventional understanding of time, behaving in ways that appear to contradict the steady, linear flow we experience in our everyday lives. AI models, however, possess the unique capability to simulate these chaotic behaviors, offering us potential glimpses into how time itself might be intricately woven into the very fabric of the universe. This opens up fascinating new discussions regarding whether time is an inherent and fundamental aspect of reality, or merely a construct shaped by the mechanics of the universe and our perception of it. Another surprising and intriguing discovery relates to the concept of time dilation. The idea that time is not a fixed, universal experience, but rather one that is perceived differently depending on the speed of an object and the strength of the gravitational fields it encounters. AI systems have been at the forefront of analyzing vast amounts of data from a range of experiments and observations, revealing a more nuanced and profound understanding of time dilation than ever before. By synthesizing data from satellite imagery alongside ground-based observations, AI has been able to model the complex relationship between high-speed travel and the passage of time, demonstrating the subtle yet profound effects these forces have on our experience of reality. Furthermore, the predictive capabilities of AI are beginning to revolutionize our relationship with time itself. By examining historical data, social dynamics, and patterns across various fields, AI can forecast future trends with remarkable precision. This leap forward does not just impact fields like economics and sociology. It invites us to reconsider time not merely as a static metric, but as a fluid concept, subject to numerous influencing factors. These insights are reshaping our understanding of time, emphasizing its dynamic, multifaceted nature and the profound role artificial intelligence plays in unveiling one of the universe's most elusive and profound elements. As AI continues to evolve, so too will our insights into the very essence of time. This ongoing evolution prompts reflection on how time is structured in both the natural world and within our human experience. For instance, meteorological cycles and celestial events provide fascinating examples of how time is organized and perceived. Take, for example, the changing of the seasons. This natural cycle, tied intrinsically to the Earth's orbit around the Sun, unfolds with predictability, each season lasting roughly 3 months, accompanied by distinct weather patterns and shifts in temperature. These cyclical rhythms help humans structure their lives, plan for the future, and adapt to the changing environment. However, they also serve as a reminder that time, though measured by calendars, is deeply connected to larger cosmic forces that govern the motions of our planet. Turning our attention to celestial events, we encounter yet another layer of complexity. Phenomena like eclipses, comets, and planetary alignments highlight the intricate relationship between time and the cosmos. A solar eclipse, for instance, occurs when the moon passes directly between the Earth and the Sun. This rare and awe-inspiring event follows specific intervals, which can be accurately predicted through historical records and modern calculations. Such celestial occurrences evoke a sense of wonder, revealing the deep historical significance ancient civilizations placed on observing and tracking time. They constructed elaborate calendars and rituals centered around these cosmic events, illustrating that time was not only a measure of earthly activities, but was also intrinsically connected to the heavens. The synchronization of weather patterns and celestial movements further illustrates that time is not a static, fixed entity. Rather, it is shaped by natural rhythms that ebb and flow, making it feel elastic at times. While we may experience days, months, and years as predictable units, our perception of time can shift dramatically depending on the cycles that surround us. During rare celestial events, for example, it is as though time itself pauses as we become fully immersed in the extraordinary spectacle unfolding in the skies. Understanding these cycles, whether they are linked to the Earth's movements, the phases of the moon, or the grandeur of distant stars, offers valuable insight into the layers of time, revealing that it is both a personal experience and a universal constant. As we peer further into the cosmic fabric of time, we encounter some of the universe's most profound mysteries, enigmatic phenomena that continue to challenge the boundaries of our scientific knowledge. One such mystery is dark matter, a form of matter that cannot be observed directly because it does not emit, absorb, or reflect light. Despite its invisibility, dark matter is inferred through its gravitational effects, which influence the rotation of galaxies and the behavior of other celestial objects. Its presence reveals that the universe contains hidden dimensions and forces still beyond our grasp that shape the structure and dynamics of everything from the smallest particles to the largest galaxies. Closely related is the concept of dark energy, a mysterious force thought to be driving the accelerated expansion of the universe. While we can measure the effects of this expansion, the underlying cause remains elusive. Dark energy challenges our understanding of gravity and the very future of the cosmos, suggesting that there are forces at play, forces we have yet to fully comprehend, that could ultimately determine the universe's fate. Quantum entanglement is yet another fascinating enigma that defies our conventional understanding of space, time, and causality. When particles become entangled, their states are instantaneously linked, such that the state of one particle influences the state of another, no matter how far apart they may be. This seemingly instantaneous connection between distant particles raises profound questions about the nature of reality itself, suggesting that space and time may not operate as we intuitively believe. These quantum phenomena, as strange and mind-bending as they are, serve as a window into the deeper mysteries of the universe, where time and space may be far more interconnected and fluid than we could ever have imagined. The phenomenon of fast radio bursts, FRBs, brief and intense flashes of radio waves originating from distant regions of space, adds another layer to this cosmic puzzle. The exact source of these bursts remains a subject of debate, with theories ranging from neutron stars to the exotic possibility of alien civilizations. What is certain, however, is that the immense energy and sudden appearance of these bursts represent a tantalizing mystery that continues to captivate astronomers and physicists alike. Like dark matter, dark energy, and quantum entanglement, FRBs challenge our understanding of the universe, pushing the boundaries of scientific inquiry and sparking the imagination of those seeking to unravel the cosmos's deepest secrets. These mysteries, while captivating, are not merely intellectual curiosities. They pose fundamental questions about the very nature of time, space, and existence itself. As our technological capabilities and understanding of the universe advance, each new discovery opens up more questions that beckon us to dig deeper and to rethink everything we know about the cosmos. The pursuit of knowledge is a never-ending journey, and as we continue to push the frontiers of science, we find ourselves drawn ever more deeply into the search for answers. Time itself has always held a magnetic allure for humanity. From the fleeting beauty of a sunset to the vast stretches of cosmic history, time shapes every facet of our existence. It has captivated thinkers for millennia, raising fundamental questions about its nature, its flow, and what lies beyond our perception of it. This fascination has fueled scientific exploration, artistic expression, and philosophical inquiry, as people seek to understand not only how time shapes our lives, but also what it truly is. Is time a tangible physical entity that flows, or is it more of an abstract construct of our minds, a way to measure and make sense of change in a universe that is anything but static? Scientists and philosophers have long grappled with these questions. The search for the true nature of time drives research into the most fundamental aspects of the universe, questioning whether time exists independently of us or whether it is merely a measurement of events that occur within it. The concept of the beginning of time, particularly in relation to the Big Bang, raises further profound inquiries. If time began with the birth of the universe, what, if anything, existed before that moment? What are the implications for our understanding of causality, the arrow of time, and the unfolding of events throughout history? The relationship between time and space is also crucial to our understanding of the universe. According to Einstein's theory of relativity, time behaves differently depending on the strength of gravitational fields. Time moves more slowly in stronger gravitational fields, which has profound implications for everything from the experiences of astronauts traveling through space to the behavior of objects near black holes. These variations in the passage of time illustrate just how much our perception of time can be influenced by the forces around us, and how the experience of time itself is deeply connected to the broader fabric of space and gravity. Lastly, the idea of time travel has long captured the imagination of both scientists and the general public. Can we ever travel backward or forward through time? Though many theories suggest possible pathways, such as traveling through wormholes or harnessing the effects of relativistic speeds, no practical method has been discovered. Yet the very exploration of these possibilities raises fundamental questions about the nature of reality, free will, and destiny, prompting us to reconsider our understanding of time and its potential to shape not just the past and the present, but the very future itself. Thus, the exploration of time remains one of the most profound, challenging, and awe-inspiring quests of human knowledge, one that continues to push the boundaries of science and spark the imagination of all who dare to wonder about the mysteries of the universe. Time, the invisible thread that weaves through every moment of our existence, continues to captivate and mystify both scientists and philosophers. It raises profound questions about the very nature of human consciousness. How does our brain perceive time? Why does it sometimes feel as though time accelerates, only to slow to a crawl in other moments? What are the forces behind the way we experience time, and how does this perception influence our emotions and cognition? These questions not only intrigue, but drive scientists to search for deeper insights into the inner workings of our minds. Each discovery brings us closer to unraveling the complex and enigmatic phenomenon we call time. The passage of time is not merely a series of numbers ticking by on a clock. Time is inherently unpredictable, spontaneous, and full of surprises. When we consider spontaneity, we often think of sudden, unanticipated events, moments that disrupt our routines and alter the course of our lives. A surprise encounter, an unexpected opportunity, or a chance event can forever change our trajectory. These moments of surprise show us how fluid our relationship with time can be, constantly shifting in response to unforeseen occurrences. Similarly, unpredictability plays a central role in our experience of time. Though the universe operates under fixed laws, Newton's laws of motion, Einstein's theory of relativity, there remains an inherent uncertainty, particularly in the realm of quantum physics. In the quantum world, particles do not behave according to predictable patterns. Instead, they exist in states of potential, not fixed reality. This unpredictability suggests that even at the most microscopic level, time is deeply intertwined with chance and uncertainty. It is as if time, rather than being a straight line, is a journey through an ever-changing, unpredictable landscape. Together, spontaneity and unpredictability infuse time with mystery. Though we can measure it, track its passage, and observe its effects on our world, we cannot always predict or control how it unfolds. Time is both a guide and a riddle, a puzzle we attempt to solve but can never fully master. Every moment, every tick of the clock offers an opportunity for discovery and understanding, pushing us to engage with the ever-shifting nature of our reality. Through the lens of cognitive science, we gain a fascinating perspective on how time exists not only as a unit of measurement, but as an intrinsic part of human experience. Cognitive scientists study how we process and understand time, revealing that time is far more than a mere tool for ordering events. It is something our brains experience in deeply personal and often surprising ways. Consider, for example, how our perception of time can stretch or shrink depending on our emotional state or level of attention. A thrilling roller coaster ride filled with excitement and adrenaline may seem to pass in the blink of an eye, while a mundane lecture can feel as though it stretches on for hours. This subjective experience of time, its stretching and compressing based on context, reveals how closely linked time is to our emotions and mental focus. Cognitive scientists explore how the brain processes time, unraveling the mechanisms that govern our sense of past, present, and future. Some areas of the brain are dedicated to measuring the duration of time, while others help us sequence events in a meaningful way. These processes allow us to not only understand the chronological order of events, but also to anticipate what may happen next. The concept of mental time travel illustrates this idea. Our minds can drift backward, recalling past memories, or leap forward, imagining future possibilities. This remarkable ability is essential for planning, decision-making, and survival. However, our perception of time is not solely determined by biology and neuroscience. It is also shaped by culture. Different societies place varying levels of importance on time. In some cultures, punctuality is prized and a rigid sense of schedule is deeply ingrained, while in others, time is viewed as more fluid and flexible. These cultural norms influence how individuals within these societies experience time, shaping not only personal habits but collective behavior. The intersection of psychology, neuroscience, and philosophy within the field of cognitive science helps us understand not just how we perceive time, but how our perception of time, in turn, shapes our consciousness and social reality. Research in neuroscience has uncovered further insights into how our brains process time, revealing that our experience of time is not simply a passive flow, but an active, dynamic process. Time is not a linear flowing stream. It is a complex, multifaceted phenomenon. For example, when we engage in an exciting or novel experience, our brains are working overtime to process the wealth of new information. This heightened engagement creates vivid memories, making the experience feel longer. On the other hand, during routine activities, the brain processes familiar stimuli with less intensity, leading to fewer memorable moments and giving the illusion that time is speeding up. This is why we often say that time flies when we're having fun, but drags when we're bored. Another fascinating aspect of our experience with time involves attention and emotion. When we are intensely focused on a task or emotionally invested in an event, time often seems to distort. In moments of fear or exhilaration, for example, our perception of time may slow down. The brain prioritizes these emotionally charged moments, committing them to memory in vivid detail, which gives the illusion of time passing more slowly. The brain's internal clock, which helps us gauge time, is influenced by multiple neural regions, and disruptions in this system can lead to distorted perceptions of time, as seen in certain neurological conditions. Understanding the brain's processing of time has profound implications not only for our understanding of time itself, but also for the nature of human consciousness. Time perception is deeply subjective, shaped by the intricacies of our mental state, the events we encounter, and the environment around us. By exploring how we perceive time, scientists and philosophers gain deeper insight into the mysteries of consciousness, the very fabric of what it means to be human. Furthermore, changes in consciousness, such as those that occur during sleep or dreaming, offer another window into how our perception of time can shift. During waking hours, external cues, like the ticking of a clock or the rhythm of our daily routines, provide a sense of structure that helps us navigate the passage of time. But in the realm of dreams, these cues disappear. Dreams can feel as though they stretch for hours, even though only a few minutes have passed in reality. This distortion happens because the brain remains active during sleep, processing memories and emotions as it does when we are awake. The vividness and intensity of dreams blur the boundaries of time, making it seem as though we are embarking on entire journeys, even though only a fraction of time has passed. This phenomenon is not just a curious quirk of the sleeping mind. It has implications for our understanding of how consciousness and time are intertwined. The fluidity of time in dreams challenges our conventional understanding, reminding us that time is not a fixed, measurable entity, but rather a construct that can be reshaped by the mind itself. In this way, dreams provide us with a unique lens through which to explore the deeper questions of time, consciousness, and reality. In the end, the question of how time affects human existence and consciousness is not one that will be easily answered. But with each step forward in science and philosophy, we inch closer to understanding the true nature of time, an understanding that promises to illuminate not just how we perceive time, but who we are as individuals, as conscious beings, and as participants in the grand unfolding mystery of existence itself. Altered states of consciousness have long intrigued both scientists and philosophers, offering a unique glimpse into the malleable nature of our perception of time. Through practices such as meditation or during experiences induced by psychedelics, individuals often enter realms where the flow of time becomes indistinct, distorted, or even entirely dissolved. As we delve deeply into thoughts or sensations, we may experience time not as a linear progression, but as a vast, interconnected landscape where past, present, and future intertwine. It is during these moments that we begin to realize how subjective time truly is, and how it can stretch, bend, and even loop back on itself in a manner that challenges our everyday understanding. In these altered states, the passage of time can seem entirely fluid, challenging the notion that time flows uniformly from one moment to the next. Under the influence of certain substances, many individuals report a sensation of time elongating. What might feel like hours could pass in what feels like mere minutes. Alternatively, the past may lose its distinct edges, merging into the present as if there were no clear division between memory and lived experience. This profound fluidity of time reveals something deep about the brain's role in constructing our perception of reality. Time is not just a mechanical progression, but is heavily shaped by our emotions, sensory experiences, and cognitive state. Rather than adhering to an inflexible quantitative framework, time is shaped by context and the mind's interpretation of it. This realization can be a gateway to profound insights about the nature of existence itself. The rigidity with which we often view time, encapsulated by a steady forward march, begins to crumble, making room for a more dynamic understanding of reality. We might come to see time less as a straight line and more as a rich tapestry, woven from memories, emotions, and fleeting moments. In this view, time itself becomes an expression of our consciousness, one that is open to subjective interpretation and, perhaps, malleability. Psychedelic experiences in particular often amplify these realizations, revealing that time is less about the ticking of clocks and more about shared human experiences. It is through these experiences that individuals may feel a profound sense of interconnectedness, transcending the boundaries that time seemingly places between people, events, and moments. This expanded understanding of time can also foster greater mindfulness and appreciation of the present moment. Rather than viewing life as a series of moments slipping away from us, we may come to see it as an ongoing series of deeply engaged experiences. Here, life is not measured in seconds, but in the quality of the moments we share. As we age, the perception of time shifts once more. When we are young, every experience is new, vivid, and brimming with discovery. A single week filled with new activities and first-time experiences can feel endless. Childhood is a time of constant learning, where each day might be packed with unforgettable milestones. A first bicycle ride, the first taste of ice cream, the first day of school. Time stretches under the weight of novelty, each moment expanding with possibility. However, as we grow older, life tends to settle into routine. Days blur together as familiar patterns take over, and the novelty that once made each day feel fresh begins to fade. The more familiar experiences become, the less distinct they feel in memory. Time doesn't seem to slow down or speed up. Rather, it feels as if it's compressing because our brains simply register fewer new, vivid experiences. This sensation of time accelerating is not due to any inherent change in the passage of time itself, but because our cognitive processes are less attuned to routine events. The brain processes novel experiences more deeply, making them easier to recall, while repetitive experiences leave fewer lasting impressions. As a result, we may feel that time is flying by, even though the minutes and hours are still the same. The way memories are formed also plays a role in our shifting perception of time. Younger individuals tend to form rich, detailed memories of events, creating vivid markers along the timeline of their lives. Older individuals, however, may find that their memories fade with time, becoming more abstract or indistinct. This shift in memory formation may contribute to the feeling that time is moving more quickly as we age. Fewer distinct memories mean fewer clear markers of time past. For instance, a summer vacation spent in a new and exciting place can feel expansive, filled with a wealth of new experiences. But a summer spent in the same environment with fewer new or stimulating experiences may seem to pass in the blink of an eye. Emotional states also profoundly shape how we perceive time. Moments of intense joy or fear can seem to stretch on endlessly, while periods of relaxation or boredom can seem to pass in the blink of an eye. The emotional weight of an experience can cause time to feel slow, while moments of excitement can make it feel as if hours slip away in mere minutes. Understanding this emotional influence on time perception suggests that the passage of time is not just a physical phenomenon, but one that is deeply intertwined with our psychological state. As we grow older, we may seek to counteract this perceived acceleration by deliberately creating new experiences, allowing us to slow down the rush of time and make each moment feel fuller. By staying open to new activities, pursuing novel interests, and embracing the unexpected, we can reintroduce the sense of discovery that once made time feel expansive and meaningful. Throughout the history of science, the concept of time has been one of the most complex and debated subjects. Classical thought experiments have played a pivotal role in reshaping our understanding of time. One of the most famous is Albert Einstein's train thought experiment, which challenges our assumptions about how time is experienced in different frames of reference. Imagine a train moving at high speed, with an observer on a platform watching two lightning bolts strike either end of the train simultaneously. From the perspective of someone aboard the train, however, the strikes would appear to occur at different times due to the motion of the train. This illustrates the idea that time is not an absolute, unchanging quantity, but is instead relative to the speed of the observer. Another landmark thought experiment is the twin paradox, which arises from the theory of relativity. In this scenario, one twin travels into space at nearly the speed of light, while the other remains on Earth. Upon the spacefaring twins' return, they discover that they have aged less than their sibling who stayed behind. This paradox illustrates how time can elapse at different rates depending on an individual's velocity, raising profound questions about the uniformity of time across different observers and challenging the notion of time as a universal constant. Time travel, too, has sparked countless debates and paradoxes. What happens if we could go back in time to change a significant event, such as preventing the death of a loved one? The famous grandfather paradox raises the possibility that a time traveler could inadvertently alter their own past, preventing their existence. Such paradoxes challenge our understanding of time, not as a linear progression, but as a more intricate, flexible fabric, one that is capable of being warped by actions and decisions. These thought experiments invite us to reconsider time not as a rigid backdrop against which events unfold, but as a dynamic entity interwoven with space, perception, and possibility. The exploration of time's complexities extends into the realm of hypothetical scenarios. What if time did not flow uniformly for everyone? Imagine two people observing the same event. One is standing near a massive object like a planet, while the other is far away. The person near the planet would experience time flowing more slowly due to the effects of gravity. This thought experiment illuminates how gravity itself influences the passage of time, showing that time is not just affected by velocity, but also by the gravitational forces at play in the universe. Such hypothetical situations serve as a powerful tool for deepening our understanding of time. By imagining scenarios where time behaves in unexpected ways, we stretch the limits of our conceptualization, opening our minds to the possibility that time is far more malleable and dynamic than we initially thought. Through these thought experiments, we are invited to appreciate the remarkable and sometimes mind-bending nature of time as it adapts to the forces of the universe. To truly challenge the illusion of time, we must first ask fundamental questions. What is time? How do we define it? At its core, time is often described as a measure of change, a way to sequence events. It flows continuously, but the nature of this flow remains elusive. How do we perceive time? Our senses create the impression of time passing, but that perception can vary dramatically depending on our emotional state, our level of engagement, and our environment. Does time exist as an objective reality, or is it a psychological construct shaped by our minds? We must also consider whether time is the same for everyone. Scientific theories suggest that time can stretch and compress depending on factors such as speed and gravity. Is it possible for two individuals to experience time in different ways depending on their location or movement? This question leads to a deeper exploration of how time is intertwined with the fabric of the universe. How does time relate to other dimensions, especially in the context of relativity? Time, as we know it, is not a standalone entity. It is interwoven with space, forming the framework of space-time. This connection raises questions about the very foundation of reality itself, and the possibility that time might behave differently under extreme conditions. Finally, we must consider the arrow of time, the notion that time flows in one direction, forward. This unidirectional flow appears to be tied to the increase of entropy or disorder in the universe. Why does time seem to move forward and not backward? Understanding this fundamental aspect of time can shed light on broader concepts of existence, change, and the nature of the universe itself. As we grapple with these questions, we begin to peel back the layers of time, revealing its complexities and the profound impact it has on our understanding of reality. Through philosophical inquiry, we are challenged to think critically about the very nature of time, urging us to question whether it truly follows a linear progression or if it exists in multiple forms simultaneously. As science continues to investigate time from the perspective of relativity and quantum mechanics, we find that our assumptions about time, so often taken for granted, are far from simple. Time, it seems, is not just a backdrop for events, but an intricate, ever-evolving aspect of the universe itself, shaping and being shaped by the forces of space, gravity, motion, and perception. The exploration of time is an ever-evolving conversation that intersects various realms of human understanding, from science and technology to philosophy and spirituality. As we delve deeper into these discussions, we can anticipate not only the refinement of our technical capabilities, but also the birth of new methodologies for unraveling the mysteries of the universe. Take, for example, advancements in space exploration, where we continue to develop more precise ways to study the cosmos. Similarly, we can envision the future of time travel, an idea that once existed purely in the realm of fiction, but is now under serious scientific inquiry. The fusion of philosophical contemplation with scientific investigation creates a unique and dynamic platform for exploring such possibilities. This blend of disciplines does more than expand our knowledge base. It invites us to engage in profound reflection about our place within the cosmos. In this ongoing quest, the marriage of science and philosophy encourages us to view time not simply as a linear measurement, but as a fluid, multifaceted experience that transcends the ticking of clocks. Our understanding of time is intricately shaped by personal beliefs, cultural narratives, and spiritual perspectives. To some, time is more than just an abstraction of seconds, minutes, and hours. It encapsulates the essence of experience itself. Some cultures perceive time as cyclical, envisioning it as a never-ending loop, where the past continually repeats itself. Others see it as a linear progression, where time moves from the past through the present and into the future. In these varying interpretations, time often takes on a more spiritual dimension, prompting us to reconsider its true nature. Within the realms of spirituality and philosophy, time is frequently regarded as an illusion. This perspective suggests that our obsession with past regrets or future anxieties detracts from our ability to be fully present in the moment. Various schools of thought emphasize the idea that the present is all that truly exists, urging us to embrace mindfulness and immerse ourselves in the now. By doing so, we may discover a more intimate connection to our immediate surroundings, ultimately leading to greater emotional and spiritual fulfillment. Moreover, some spiritual traditions propose that our perception of time is not solely governed by the ticking of a clock, but is deeply influenced by consciousness itself. In these views, time becomes a fluid experience that can stretch or contract depending on our emotional or spiritual state. For instance, moments of intense joy, fear, or deep reflection might feel as though they are suspended in time, while periods of monotony or routine might pass in the blink of an eye. This flexible nature of time challenges the conventional understanding of it as a rigid, objective measure, instead framing it as a subjective experience, one that is personal, emotional, and constantly in flux. The intersection of personal beliefs, spirituality, and the perception of time is a rich and complex tapestry that encourages us to explore beyond the confines of scientific definitions. It invites us to question our relationship with time and consider its deeper implications in our lives. This union of subjective experience and cultural narratives enriches our collective conversation about time, providing us with new ways to understand its true nature and impact. It's here that science and spirituality converge, offering a fascinating glimpse into how both realms can coexist and complement each other, creating a more holistic view of the universe. One of the most compelling ways to understand the elusive nature of time is through imagery and metaphor. When we envision time as a river flowing steadily along its course, we can easily relate to the way it can quicken or slow, reflecting the varying speeds at which we experience life. Moments of profound intensity may seem to stretch on forever, while mundane or routine periods may feel fleeting. This river metaphor is a powerful tool, illustrating that although time moves forward unceasingly, the way we experience it is not always uniform. Similarly, the metaphor of time as layers of an onion is another way to visualize the passage of time. Each layer represents a different moment, a different memory, and as we peel away these layers, we can begin to understand how our past experiences shape our present perceptions. In this view, time is not merely a straight line, but a multidimensional experience, rich with connections and interwoven moments that influence and inform one another. Then there is the image of time as a stretched rubber band, an analogy that speaks to the flexibility of time. In moments of joy or excitement, time seems to fly by, while during sorrowful or difficult times, every second can feel like an eternity. This elastic nature of time, its ability to expand and contract based on our internal experiences, underscores the subjective quality of time. It invites us to consider how time is not just a scientific concept, but an emotional and personal one as well. The use of visual metaphors can also help to translate the intangible concept of time into something more concrete and relatable. Imagining time as a river or a fabric weaved together with various events and experiences allows us to connect abstract ideas with our everyday experiences. These metaphors not only offer clarity, but they also help us deepen our understanding of time's impact on our emotions and memories. Animation and digital effects have introduced even more innovative ways to explore our understanding of time. In visual storytelling, creators often manipulate speed, motion, and perspective to convey the subjective nature of time. For instance, imagine a scene where a character is moving through a space, but the world around them seems to be speeding up or slowing down. This visual contrast evokes a sense of time distortion, allowing us to experience time in a way that feels both disorienting and familiar at once. By altering the speed of movement, filmmakers can create a sense of moments that stretch or compress, providing a unique lens through which we can explore the passage of time. Similarly, techniques such as time-lapse photography compress long spans of time into brief, captivating sequences. The rapid blooming of a flower or the transition from day to night in a matter of seconds not only highlights the passage of time, but also reinforces the idea that while we experience time in a linear fashion, it can also be viewed in snapshots, flashes that represent pivotal moments of change. In this way, time becomes less of a continuous march and more of a series of moments that stand still, each representing a unique story. Furthermore, digital effects can be used to illustrate the scientific phenomenon of time dilation. As we know, time behaves differently under varying conditions, particularly in areas of high gravity or immense speed. In the context of a story, this could be depicted by visualizing how time slows as a spaceship approaches a black hole, for instance. The distortion of space and time itself serves as a reminder that our perception of time is not always in alignment with the reality around us. These visual techniques are not merely artistic choices, but serve to challenge our preconceived notions of time. They prompt us to think about how our perception of time might be altered by external forces, whether that's the vastness of space, the bend of gravity, or the fleeting nature of the human experience itself. Through these powerful methods, filmmakers and creators open the door to a world where time is not just a ticking clock, but a fluid, ever-shifting force that shapes our reality in ways both subtle and profound. In addition to visual techniques, storytelling itself often serves as a means to explore the illusion of time. Nonlinear narratives, for example, allow us to experience time out of order, jumping between the past, present, and future in ways that reflect the complexities of memory and perception. In doing so, they suggest that time is not a constant, but rather a malleable concept that is experienced differently by each person, each character. This narrative approach emphasizes how our understanding of time is shaped by the connections we make between different moments in our lives. Artists, too, use their medium to explore the nature of time. Through painting, sculpture, or photography, they capture scenes at various points in time, often showing how light, atmosphere, and other factors change over the course of the day. These works challenge us to think about whether time is a fixed and unchanging reality, or whether it is a construct that shifts based on perspective. Sound and music also play an essential role in shaping our understanding of time. Composers use rhythm and tempo to evoke feelings of urgency or calm, slowing down or speeding up the passage of time. In sound design, layered sounds or echoes can evoke a sense of the past lingering in the present, further reinforcing the notion that our experience of time is not merely linear, but rather a complex interplay of emotions, memories, and physical reality. Ultimately, time is not just a concept confined to the realms of science or philosophy. It is a deeply personal and emotional experience that is shaped by how we live, feel, and interact with the world around us. By using visual metaphors, digital techniques, and storytelling, creators of all kinds invite us to question our assumptions about time, urging us to reflect on how it shapes our lives and our understanding of existence itself. Time, after all, is not just something we measure. It is something we experience, and it is this experience that continues to captivate and intrigue us. Time is often perceived as an unwavering constant, a force that flows seamlessly from the past through the present and into the future. Yet the very nature of time is far more complex than this simple linear view suggests. Visual techniques in filmmaking, such as the gradual transformation of colors and lighting, can evoke a profound sense of time's passage. As the light shifts from the warm, golden hues of dawn to the cool, bluish tones of dusk, it not only creates a natural depiction of time's progression, but it also invokes emotions of nostalgia, longing, or anticipation. This transition from one color palette to another doesn't just illustrate time passing. It speaks to the deeper emotions tied to those fleeting moments. The beauty of these changes, the soft blending of light and shadow, draws attention to the impermanence of life itself. Furthermore, integrating character experiences into these scenes deepens our connection to the passage of time. Following a character's journey through significant life events, whether joyous or sorrowful, helps humanize the abstract concept of time. Viewers don't merely witness time as a ticking clock. They experience it through the character's personal transformations, through their growth, their losses, their triumphs, and their setbacks. These moments resonate on a personal level, inviting audiences to reflect on their own relationships with the passage of time. Time, in this context, becomes something far more intimate and profound, not merely a series of ticking seconds, but a force that shapes lives, dictates choices, and alters destinies. Cosmologically, time challenges our everyday understanding even further. Traditionally, we view time as a simple progression, a steady river flowing from the past into the future. But as we look deeper into the realms of physics, particularly in theories like block universe theory, this view begins to unravel. Block universe theory suggests that all moments, past, present, and future, exist simultaneously, creating a timeless block where time as we experience it is simply a shift in perspective. It's akin to looking at a painting where every part of the artwork exists at once, but our attention moves from one detail to the next, framing each moment differently. In the world of quantum mechanics and relativity, time doesn't flow uniformly. In fact, Einstein's theory of relativity proposes that time itself is elastic. It stretches and compresses depending on speed and gravity. This idea forces us to reconsider time's reliability. Could it really be the same for everyone, everywhere? In areas with stronger gravitational fields, near black holes or massive stars, time slows down. What's more, the faster an object moves, the slower time appears to pass for it. The implications of this phenomenon are staggering. Time, it seems, is not an immutable constant, but a malleable variable, one that bends and shifts in response to cosmic forces. These revelations about time suggest that it might not be a fundamental property of the universe, but rather an emergent quality, a byproduct of deeper physical processes. The steady ticking of a clock, it turns out, might be nothing more than an illusion shaped by our limited perceptions and the complex interactions of cosmic forces. If we think of time as a block of moments rather than a flowing river, we might begin to understand it as an intricate tapestry, a massive interconnected web of events that unfold simultaneously. Every thread of this tapestry exists all at once, shaping and defining our place in the universe. Cosmic phenomena such as the movement of stars, the expansion of galaxies, and the birth and death of celestial bodies offer a striking perspective on time. When we gaze up at the stars, we aren't simply looking at distant lights in the sky. We are seeing moments that have traveled vast distances over millions, even billions of years. The light that reaches us today may have left a star at the very moment of its birth or death, carrying with it a glimpse of the past, a snapshot frozen in time. These distant lights are not only markers of space, but markers of time itself. The farther away a galaxy is, the further back in time we are looking. Each light year represents a journey across time, a journey that brings the distant past into our present. The universe's expansion plays a significant role in reshaping our perception of time. As the universe expands, galaxies move further apart from one another, stretching the fabric of space itself. The farther a galaxy is, the longer its light takes to reach us. This means that when we observe a galaxy billions of light years away, we aren't just looking at it as it is today. We're looking at a snapshot of its distant past. This relationship between distance and time provides key insights into the universe's history, offering a cosmic timeline that stretches back to the very beginning of the cosmos itself. Gravitational forces also influence time in fascinating ways. Near massive objects like black holes, time behaves differently than it does on Earth. A phenomenon known as time dilation occurs. The stronger the gravitational field, the slower time moves. This means that a clock near a black hole, or even on a planet with a strong gravitational pull, would tick at a different rate compared to one on a smaller, weaker moon. This stretching and contracting of time in response to gravity reveals how deeply interconnected time is with the very fabric of space. When we observe gravitational waves, ripples in spacetime caused by massive cosmic events, such as colliding black holes or neutron stars, we witness another profound example of time's malleability. These waves carry information about the cataclysmic events that produced them, allowing us to observe moments in time that were previously invisible to us. The detection of gravitational waves demonstrates that time is not a singular, unchanging path. It is a dynamic, interconnected web that can be influenced, shaped, and even distorted by the forces of the universe. One of the most striking examples of time's fluidity is the explosion of a supernova, the death throes of a massive star. When a star runs out of fuel, it collapses under its own gravity, releasing a burst of light that travels across the universe, often taking millions or even billions of years to reach us. By the time the light from a supernova reaches Earth, the star may have already been long gone. What we are witnessing is not an event happening in the present, but an echo from the past, illustrating how time can stretch across vast distances and be perceived differently depending on our location in the universe. Pulsars, highly magnetized neutron stars that emit beams of radiation, offer another fascinating glimpse into the nature of time. These stars rotate at incredible speeds, sending out regular pulses of energy, much like the ticking of a cosmic clock. However, depending on where we are in relation to the pulsar, time appears to tick at different rates. This phenomenon, influenced by the force of gravity, shows us how time can bend in the presence of massive objects, further reinforcing the idea that time is not an absolute, unchanging entity, but one that can vary across the vast reaches of space. Through these cosmic events, supernovae, pulsars, and gravitational waves, we come to understand time in a new light. Time is not a simple, unalterable force, but a fluid, dynamic entity shaped by the grand mechanisms of the universe. It is deeply intertwined with the fabric of space itself, influenced by gravity, motion, and the immense distances that separate us from the furthest reaches of the cosmos. As we contemplate time's role in the universe, we are forced to reconsider our everyday understanding of it. Time is not just a measure of minutes, hours, and years. It is a cosmic force, a vast living tapestry woven into the very fabric of existence. The more we learn about the universe, the more we realize that time, in all its complexity, is far more profound than we ever imagined. The theory of relativity fundamentally alters how we understand time, particularly in relation to the expansive and evolving universe. According to this theory, the rate of time's passage is not fixed. Rather, it is influenced by gravitational fields. Where gravity is stronger, such as near massive celestial objects like stars, black holes, or planets, time flows more slowly. Conversely, in areas with weaker gravitational influence, time passes more quickly. This phenomenon, known as time dilation, underlines the malleability of time within the vastness of space. As the universe continues to expand, the influence of gravity stretches across its fabric, warping the experience of time in ways that are not immediately perceptible in our daily lives, but are crucial when observing the cosmos on a larger scale. While we perceive time as a constant flow, defined by clocks and schedules, the expansion of the universe and the presence of powerful gravitational forces reveal that time is far from a uniform experience. In some places, time might stretch; in others, it might compress, impacting not just the movement of objects, but also the very perception of existence itself. This complex relationship between space, time, and gravity is not a modern discovery. Throughout history, various cultures and civilizations have sought to understand and interpret time's mysteries. Myths and legends have often served as mirrors reflecting the intricate relationship between human experience and the inexorable passage of time. Many cultures throughout history perceived time not as a straight line, but as a cyclical force. Time was not something that merely moved forward in one direction, but was instead part of an endless cycle, constantly recurring in loops of creation and destruction, birth and rebirth. The ancient Hindu concept of yugas, for example, describes an eternal cycle of ages, where each yuga represents a distinct era of creation and destruction, continuously evolving in a grand rhythm. This view of time suggests that the universe is in a constant state of regeneration, and time itself is not linear but cyclical, repeating in infinite patterns. In contrast to this view of cyclical time, other cultures saw time as a linear journey, moving from a clear beginning toward an eventual end. The ancient Greeks, for instance, personified time through the figure of Kronos, the god who embodied the relentless march forward of time. Kronos was not merely a passive observer, he was a powerful force, driving the inevitable decay and transformation of all things. His role in Greek mythology illustrates the idea of time as a force of change and fate, one that dictates the progression of events and the unfolding of destiny. This portrayal underscores the tension between human agency and the power of time, suggesting that while we may strive for control over our lives, we are ultimately subject to time's inexorable flow. Moreover, some myths and legends delve into the intriguing concept of time dilation, where beings experience time differently depending on their circumstances. In Welsh mythology, for example, the hidden land of Tiog is a place where time does not function as it does in the mortal realm. Travelers to Tiog can leave for what seems like only a short time, only to return to find that many years have passed. This mirrors the concept of time dilation in physics, where different gravitational fields cause time to move at different rates. In this myth, time is a force that can stretch and compress depending on where one is located in the universe, resonating deeply with modern scientific principles. These cultural stories are not just about explaining time in abstract terms, they are a reflection of humanity's attempts to come to terms with time's effects on life, death, and destiny. Through these legends, we encounter complex insights into how different cultures perceive their place in the universe, the flow of time, and the inevitable passage of life. These ancient narratives offer more than explanations. They provide profound existential insights, blending cultural values with the mysteries of the cosmos. The passage of time becomes not just a scientific question, but a deeply philosophical one, asking us to reflect on how we understand the past, present, and future. Cultural icons and figures in these stories often serve as powerful representations of time. In many myths, wise old figures or sages represent the accumulation of knowledge and experience over the course of time. These figures, often depicted as elderly and venerable, embody the weight of history and wisdom, showing how the lessons of the past shape the present and guide the future. In contrast, youthful protagonists often symbolize hope, renewal, and the potential for change. Their journeys through time reflect the forward-moving force of time itself, full of possibility, innovation, and progress. These characters illustrate a vision of time as a dynamic, ever-evolving force that propels societies from tradition to transformation, from the old ways to the new. The theme of time travel further explores this idea, allowing characters to move through different periods, experiencing firsthand the connections between past, present, and future. Through these journeys, audiences can witness the far-reaching consequences of decisions made in the past, understanding how actions ripple through time, affecting the course of history. The characters who travel through time often serve as bridges between eras, blending the wisdom of the past with the potential of the future, and offering a vision of time as a continuous, interconnected flow rather than a series of isolated moments. Other iconic figures associated with time include the Grim Reaper, often depicted as the personification of death. As a symbol of the inevitability of time's passage, the Grim Reaper serves as a reminder of the finite nature of life and the certainty that all things, no matter how powerful or enduring, will eventually meet their end. In many cultures, death is seen as an essential part of the cycle of life, reinforcing the idea that time is a force that cannot be stopped or reversed. These representations of death underscore the existential reality that time moves ever forward, and that all beings, human and non-human alike, must face the passage of time. As we consider these cultural figures and myths, we are invited to reflect on our own relationship with time. Whether through the wisdom of the elder, the hope of the youth, or the inevitability of death, these stories encourage us to think about our place within the ever-unfolding narrative of existence. Through them, we are reminded that time is not just a linear progression, but a force that shapes and reshapes the very fabric of life. Indigenous cultures, too, offer unique and often profoundly different perspectives on time. In many indigenous traditions, time is not viewed as a linear sequence from past to future, but rather as an interconnected web of events and experiences. Native American cultures, for example, often describe time as a wheel, where past, present, and future are interwoven, each influencing the other. This cyclical view of time emphasizes the interconnectedness of all things, suggesting that actions taken in one era can resonate across generations, impacting the future in ways that may not be immediately visible. Similarly, many Aboriginal cultures in Australia emphasize the concept of dream time, a period not bound by linear time, but an eternal moment in which the past, present, and future exist simultaneously. In this view, time is not a measurable progression, but an eternal state in which the land, laws, and ancestors are eternally present, shaping the lives of those who come after them. This perspective on time reflects a profound connection to the land and the natural world, highlighting the importance of living in harmony with the rhythms of nature. For many indigenous cultures, the cycles of the seasons, the movement of the stars, and the changes in the environment serve as markers of time, guiding people through their lives in ways that are deeply embedded in the natural world. Time is not something separate from life, but something that flows through it, connecting all living beings in a shared cyclical experience. In these indigenous traditions, we see a deeper understanding of time as a living, interconnected force, one that is inseparable from the rhythms of the earth and the cycles of life. This perspective offers a contrast to the more mechanistic, linear understanding of time that has become prevalent in modern societies. It encourages us to reconsider how we relate to time, inviting us to think more holistically about our place in the universe and our responsibilities to the land, the environment, and future generations. Ultimately, ancient myths, modern scientific theories, and indigenous philosophies all invite us to explore the complexities of time and its impact on our lives. Whether through the cyclical rhythms of nature, the relentless march of time as depicted by Chronos, or the bending of time in the presence of gravity, time continues to be a powerful and mysterious force that shapes our understanding of the universe. It is not merely a tool for measuring the passage of moments, but a profound force that defines existence itself. Through the stories we tell, the figures we revere, and the insights we gain from science, we come to understand that time is not just a measure of the past, present, and future, but a force that connects all things, transcending cultures, philosophies, and generations. Throughout history, many ancient cultures have looked to the stars and seasons, observing that time appears to flow in repetitive cycles. These cultures saw time not as a straight line, but as a vast, ever-turning wheel, marked by the ebb and flow of celestial bodies, natural events, and human experiences. This cyclical view of time, deeply embedded in mythology, suggests a timeless, interconnected web of past, present, and future. Modern astronomy, in turn, has revealed a striking parallel. The universe itself operates in vast, repeating cycles, with galaxies, stars, and planets moving through phases that echo these ancient stories. The celestial rhythm of the universe, with its vast cycles of creation and destruction, resonates with the natural patterns of time noted by our ancestors. In ancient mythologies, time was often personified, and its flow was seen as predictable, shaped by the movements of celestial bodies and the seasons. The sun's journey across the sky, the waxing and waning of the moon, and the cycles of the planets formed the foundation of ancient timekeeping systems. Today, scientists observe similar patterns as galaxies and stars travel through long cosmic cycles, each marked by their own rise and fall, expansion and contraction. There's a fascinating parallel here. Ancient stories of time were as much a reflection of the cosmos as modern astronomy is a revelation of the same rhythms. Moreover, many of the mythological concepts tied to time transcend mere storytelling and intersect with scientific inquiry. Ideas such as time travel, common in ancient folklore, are not far removed from modern theories concerning wormholes, space-time, and the possibility of altering or even reversing the flow of time. While these scientific concepts are rooted in complex mathematics and cutting-edge physics, they speak to a similar age-old human curiosity about the fabric of reality, a curiosity that has existed for millennia. This blend of ancient myth and modern science reveals an intriguing link. Both the stories of old and the latest breakthroughs in physics seek to understand the ultimate mysteries of existence, time, the universe, and our place within it. The ancient myths, though framed in symbolism and allegory, sought to answer questions that we still grapple with today. In a sense, the timelessness of these questions transcends the tools we use to explore them. Whether with the orbits of planets or the metaphors of gods and heroes, our desire to comprehend time, space, and the universe remains unchanged. While we now use powerful instruments, advanced technology, and complex mathematics to explore the universe, the essence of our curiosity about time remains strikingly constant. This connection between mythology and science offers a compelling lens through which we can view the modern theories that shape our understanding of time. For example, in many ancient cultures, time was often represented as a wheel, a turning cycle. This metaphor speaks to the interconnectedness of all things, how the past, present, and future are intertwined, and how each can influence the others. This concept of time challenges the modern linear perspective, which views time as a one-way flow, moving in a straight line from past to present to future. This ancient cyclical view aligns surprisingly well with certain scientific theories, especially those that suggest time may not follow a simple linear progression. The notion that time can loop or bend, that the past might be revisitable, or that the future is not set in stone echoes these ancient myths. Such metaphors can help make abstract scientific ideas more tangible and relatable, especially in the context of the fabric of space-time, which scientists describe as a four-dimensional continuum that can bend, stretch, and warp under the influence of mass and gravity. These mythological interpretations of time provide not only cultural insights, but also valuable metaphors for understanding scientific concepts like time dilation, which occurs near massive objects or during extreme acceleration. Just as ancient myths used time as a fluid and malleable force, modern physics allows us to envision a universe where time itself is not constant. The ancient idea of time as a flowing river, where experiences can move backward or forward, mirrors the physical reality of time dilation and the potential for time travel, ideas that are no longer confined to the realm of fantasy. Furthermore, the human experience of time, as portrayed in mythological stories, often deals with the cycles of nature, aging, and memory. These themes strike a deep chord with audiences, drawing connections between the stories of old and the scientific theories of today. As we explore the nature of time through the lens of mythology, we're reminded that time is not just a cold, abstract concept. It is something we live and experience in profoundly human ways. This blend of ancient storytelling and modern science allows for a more holistic approach to understanding time, one that nurtures both intellectual curiosity and emotional engagement. The idea of time's directionality, the so-called arrow of time, is a core concept in modern physics. This theory seeks to answer why time seems to flow in one direction, forward. At the heart of this question is the idea of entropy. In simple terms, entropy is a measure of disorder in a system. As time passes, systems tend to move from order to disorder, just as a neatly stacked set of blocks will eventually fall into disarray if disturbed. This increase in disorder, this movement toward greater chaos, is what gives time its forward direction. It's why we perceive time as flowing from the past to the present and into the future. At the same time, Einstein's theory of relativity offers a different perspective. Time, according to relativity, is not a separate entity, but is part of a larger, four-dimensional structure called space-time. Under certain conditions, such as when moving at speeds close to the speed of light or near massive objects, time behaves differently. Relativity doesn't change the fundamental direction of time, but it offers us a view where time's flow can be stretched, compressed, or altered. It presents the possibility that time could be experienced differently under certain conditions, but the fundamental direction from past to future remains intact. In addition to these physical explanations, our perception of time plays a significant role in how we experience the world. As humans, we have the ability to remember the past and anticipate the future, and this cognitive framework shapes how we understand the passage of time. While the laws of physics tell us that time moves forward, our psychological perception of it is equally important. Our memories, emotions, and anticipation of the future all influence how we experience the flow of time, creating a fascinating intersection between subjective experience and objective reality. The thermodynamic arrow of time, closely tied to the concept of entropy, provides another layer to this discussion. Imagine a room filled with both clean and dirty dishes. Over time, if left unattended, the room becomes messier. This mirrors the second law of thermodynamics, which states that in an isolated system, disorder or entropy tends to increase over time. As time progresses, systems naturally move from states of lower entropy, order, to higher entropy, disorder, and this tendency toward disorder gives time its distinct direction. Events such as a melting ice cube or a cooling cup of coffee are examples of this process in action, demonstrating how, in the universe, systems tend to evolve toward greater chaos. This concept of increasing entropy helps explain why we perceive time moving forward. In simple terms, we see the world around us becoming more disordered as time passes, and that increase in disorder gives time a clear direction. The thermodynamic arrow of time is not just an abstract scientific concept, it's a very real part of our daily experience. As we witness these changes in entropy, we understand time as moving inexorably forward, just as the universe itself is constantly evolving toward greater disorder. The relationship between reversibility and entropy adds an intriguing layer to our understanding of time. In the abstract, some processes in physics, such as the motion of particles or the flow of energy, can move both forward and backward without violating any laws. But when we consider the role of entropy, things get more complicated. As entropy increases, the likelihood of reversibility decreases. Imagine watching a cup fall and break. In theory, you could reverse the film and watch the pieces float back together. However, in the real world, the increasing disorder of the broken pieces makes it highly improbable for them to spontaneously reassemble. This increasing entropy provides a clear boundary for time's direction. Even though some physical processes may seem reversible, the overall trend of entropy toward greater disorder means that time, for all practical purposes, moves in one direction, forward. Reversing time, although an intriguing possibility in theory, would have profound implications for our understanding of causality and the flow of events. If we could travel back in time, we might encounter moments where choices, decisions, and events unfold in reverse, leading to a completely different present and future. Yet this raises another fascinating question. If we were able to change something in the past, even a seemingly minor event, how might it affect the future? Could a small alteration in the timeline have vast, unpredictable consequences? The concept of time travel challenges our understanding of history and choice, presenting a fascinating possibility that our actions, both in the present and the past, are intricately tied to the unfolding of the universe. Imagine, for a moment, a world where the flow of time is no longer a steady, unchangeable march from past to future. What if we could not only observe history, but actively revisit it, or even alter it? This would throw open the doors to an entirely new understanding of our relationship with the past. History, as we know it, is a complex interplay of evidence, witness testimony, and interpretation. If we could look back, not just through the lens of memories and records, but by physically revisiting those moments, our conception of what is true history would be radically transformed. What we once considered definitive events might be challenged, their significance questioned, and their very nature redefined. Historical narratives could shift from the certainty of established facts to a dynamic process of continual reinterpretation, based not only on the perspectives of historians and governments, but also on new, unimagined forms of evidence, possibly even experiences that transcend the limits of conventional observation. Governments, cultures, and societies might find themselves in deep contention over how the past should be understood, leading to debates that are not only intellectual but deeply political. What happens when multiple versions of history collide, each one claiming to represent the true version of events? Identity and legacy, the very foundations upon which societies are built, would no longer be static. Instead, they would become fluid, with conflicts arising over which narrative should dominate. This reimagining of the past would stir up questions about memory itself. Whose story do we tell, and whose voice gets lost in the shuffle of time? But it's not just the past that is at stake. The very fabric of the future would also come into question. The ability to observe potential futures would be equally as compelling. Imagine being able to witness the myriad paths that could unfold before us, each one offering a different set of possibilities, a different set of outcomes. Such a power might allow humanity to prepare for challenges with unprecedented foresight. Yet, as tempting as it might be to know what's coming, there's a paradox in this kind of knowledge. Could the very act of knowing the future influence how it unfolds? The future could, in a sense, become inevitable, creating a cycle where foreknowledge leads to a self-fulfilling prophecy. In this scenario, the ability to look ahead might only serve to alter the course of events in ways we could never have anticipated, blurring the lines between free will and destiny. The concept of time itself, what it is, how it works, and why it seems to march inexorably forward, has fascinated philosophers and scientists for centuries. Time is one of the most fundamental aspects of our reality, yet, despite its central role, it remains shrouded in mystery. The arrow of time, the notion that time flows in one direction, from past to future, is a concept that has long perplexed us. Why does time seem to be so relentlessly one way? Why can't we simply reverse it, or even view it from a different angle? One critical explanation lies in the second law of thermodynamics. This law, which governs the behavior of energy in closed systems, states that over time, systems tend toward greater disorder or randomness. Imagine a box of mixed-up toys. If you leave them alone, they won't spontaneously organize themselves into a neat, orderly arrangement. Instead, they become even messier. This tendency toward disorder provides a direction to time, marking a clear distinction between what has already happened and what lies ahead. This is the essence of time's flow. It's driven by the movement from order to chaos, a process that inevitably propels us from past to present and then on into the future. But while the laws of physics may explain the directionality of time, human perception adds another layer to this puzzle. Our brains are wired to remember the past and anticipate the future, creating a continuous narrative of experiences. We instinctively create a timeline of memories that strengthens the illusion of time's linear progression. Cause and effect, one event leading to another, reinforce this perception of time moving in a straight line, a steady current from one moment to the next. In more recent years, scientists have explored the nature of space-time itself. The equations of physics suggest that time could theoretically move in both directions. Yet, our day-to-day experience of reality is strictly bound by the conditions of our universe. If we were to observe particles moving backward in time, it would disrupt everything we know about how events unfold. This paradox, the fact that the fundamental laws of physics might allow for time to flow in reverse, while our personal experiences are anchored in one direction, raises profound questions about the very structure of reality. At the frontier of science, researchers continue to delve deeper into the complexities of time. Through experiments involving high-energy particles and quantum mechanics, we're gaining new insights into how time behaves at the smallest scales. But even as we make these discoveries, the fundamental question of why time flows one way and not the other remains one of the most elusive mysteries in both physics and philosophy. Looking ahead, as our understanding of time advances, it's easy to imagine a future where this newfound knowledge leads to profound shifts in society. Today, our grasp on time is largely limited to measuring it through clocks, calendars, and the cycles of nature. Time is a resource, something we measure and manage in the most practical terms. But what if we could manipulate time in ways we've only dreamed about? The potential for such control is tantalizing. Imagine a world where we could slow down or speed up time, where our understanding of time could transform how we live, work, and even age. In the realm of technology, the implications are enormous. Consider the possibility of altering our perception of time. We could develop tools that allow us to experience time more slowly or quickly, enabling us to extend our productive hours or savor moments of reflection that would otherwise seem fleeting. Such advancements could revolutionize how we approach work, allowing us to operate at a pace more aligned with our natural rhythms, or even to experience time in a way that enriches our lives. Another remarkable possibility lies in communication. If we could manipulate time itself, we might create technologies that allow us to transcend distance. Imagine speaking with someone who is light years away, yet feeling as if they are standing right next to you. This kind of real-time interaction could break down the barriers imposed by physical separation, creating a new kind of global connection. Medical advancements could also benefit from a deeper understanding of time. If scientists could discover ways to manipulate biological time, slowing aging or accelerating healing, we might one day see treatments that extend life or dramatically improve our quality of life. Imagine therapies that could make it feel as though you're recovering from an illness in the blink of an eye, or technologies that slow the aging process, allowing people to live longer, healthier lives. Beyond the realm of the physical, a deeper understanding of time could also reshape society on a philosophical level. As we begin to explore the very nature of time, we might find ourselves revisiting age-old debates about fate, free will, and the interconnectedness of all things. The more we learn about time, the more we realize that our understanding of it shapes not just our daily existence, but our very identities. What if our lives were not linear, but instead an intricate web of interconnected moments, where past, present, and future are constantly interacting? As we push the boundaries of what is possible, we could find ourselves living in a future where our relationship with time is completely redefined. And in this new world, anything, whether in technology, health, or even human experience, could be transformed in ways we can't yet imagine. Ultimately, the study of time holds the potential to reshape the future in profound ways, creating possibilities that could radically alter how we live, work, and understand our place in the universe. Moreover, envisioning energy systems that could tap into the very essence of time itself holds profound potential. Imagine a world where energy is no longer merely generated and stored in the conventional sense, but instead it flows in sync with the temporal rhythms of our needs. This vision could usher in a new era of renewable energy solutions, one so advanced that they adapt in real time to usage patterns, optimizing energy flow exactly when it's required. Such a leap in innovation could revolutionize the way we harness and consume energy, making our infrastructure vastly more efficient, sustainable, and attuned to the shifting demands of everyday life. The possibilities here are almost limitless, transforming not just how we power our world, but also how we think about energy itself. At the same time, a radical shift in our understanding of time might have far-reaching implications for artificial intelligence. Reprogramming AI systems to operate on a different temporal scale could make machines capable of solving problems at speeds once thought impossible. This could be the key to unlocking solutions for some of humanity's most pressing challenges: climate change, space exploration, disease eradication, fields that demand innovation at an unprecedented pace. With time redefined, AI could function not merely as tools, but as partners in reshaping our future. The intersection of time, technology, and intelligence could ultimately lead us to a world brimming with possibilities previously confined to the realm of science fiction. But the implications of redefining time don't stop with technology. Such a transformation would ripple through every facet of human existence, altering our perceptions of life itself. What if we could experience time not as a rigid, unyielding sequence, but as a fluid, interconnected flow? In this new framework, the linearity of past, present, and future would dissolve, allowing moments to intermingle and blend seamlessly. This shift could enrich human experience, enabling us to feel more connected to the past, present, and future simultaneously, as though life were a continuous thread rather than a series of disconnected events. This shift could also have profound implications for the way we experience our evolution as individuals and as a species. If we began to view life through this more interconnected lens, the very nature of our social structures might evolve. Instead of focusing on individual achievement, we could find ourselves moving toward more communal ways of living. Empathy, collaboration, and collective growth could become the central tenets of human interaction, with the awareness that our actions today ripple through time, affecting not just our immediate environment, but the future of generations to come. From a cognitive standpoint, redefined time might sharpen our mental faculties. With a deeper understanding of temporal fluidity, we might find our cognitive abilities stretched to new dimensions. This expanded perception could encourage profound introspection and mindfulness, unlocking creative and problem-solving potential previously untapped. Imagine approaching challenges not as isolated problems in time, but as complex phenomena that span across different temporal dimensions, giving us access to a wider pool of experiences and solutions. Such a heightened awareness of time could also alter how we process our own identities. Time as we know it could no longer be confined to the ticking of a clock or the passing of years. Instead, our sense of self could become more dynamic, more expansive, as we experience life not in rigid chapters, but in a continuous flow of interconnected moments. This new perception could deepen our connection with the natural world and the universe at large, aligning us more closely with the rhythms of life around us. As we begin to live in harmony with time, the human experience itself would be enriched, offering us deeper meaning in every moment, every encounter, and every step of our journey. These shifts wouldn't merely influence individuals, they would have cascading effects on the collective evolution of humanity. In speculative fiction, many authors have explored similar ideas, imagining worlds where time behaves more fluidly and is experienced in nonlinear ways. In these narratives, past, present, and future often coexist in overlapping layers, much like a painting with multiple interwoven scenes. Imagine a landscape where beings could step in and out of different moments in time, much as one might flip through the pages of a book or skip to different scenes in a film. In these worlds, time becomes not a constant, but a construct that can be manipulated and shaped by those who understand its deeper nature. Some stories take this concept further, envisioning civilizations that have discovered methods to transcend the usual constraints of time. People in these worlds might live without the traditional boundaries of past and future, interacting with moments as though they were events in a movie, choosing which scenes to relive or altering the course of their lives with the touch of a button. This raises profound questions about the ethical implications of manipulating time. Can changing the past erase someone's existence? Would altering one event ripple through time, affecting the future in unpredictable ways? These dilemmas are at the heart of many thrilling narratives, pushing characters to confront their understanding of time, fate, and consequence. The exploration of time in speculative fiction often goes hand in hand with deep philosophical musings on the human experience. Some stories explore how memories shape identity, suggesting that our perception of time is fundamentally influenced by our emotional experiences. As time becomes more fluid, characters might begin to question the nature of their own reality, discovering that their memories are not as fixed as they once believed. In these imagined worlds, the very fabric of reality becomes a canvas for creativity, offering endless possibilities for storytellers to challenge their audience's perceptions of existence, consciousness, and the nature of time itself. Historically, humanity has viewed time as a constant, a never-changing backdrop to our lives. Yet, as our scientific understanding evolves, especially through the advancements in fields like astrophysics and quantum mechanics, our conception of time is starting to shift. We now know that time doesn't flow uniformly across the universe. Thanks to Einstein's theory of relativity, we understand that time behaves differently depending on the strength of gravity and the speed at which we are traveling. For example, if someone were to spend time near a massive object, like a black hole, and then return to a place with weaker gravity, they might find that far more time has passed for others than it has for them. This revelation challenges the traditional view of time as a linear, universal experience, suggesting instead that time can stretch, contract, and behave unpredictably depending on where you are and how fast you're moving. What if we could harness this newfound understanding of time? Could we adjust our own perception of time, allowing for more meaningful moments of learning, creativity, and personal growth? Imagine if we could extend our ability to focus and create, all while minimizing the burdens of aging or the waiting periods that often slow down progress. This could lead to a world where time isn't something we merely endure, but something we actively shape and mold to fit our needs. It would be a world where the passage of time could be optimized, making every moment richer and more profound. Furthermore, as humanity ventures deeper into space, we may uncover new aspects of time that challenge our understanding even further. Concepts like black holes, the fabric of space-time, and the mysteries of the universe could reveal new dimensions of time, ones that transcend our current understanding. This could prompt us to rethink our place in the cosmos, shifting our cultural perspective and perhaps even our approach to life itself. Instead of living according to the rigid clock that governs our daily routines, we might find a more harmonious relationship with time, one that allows us to explore the universe without being constrained by its traditional limits. As we continue to delve deeper into the mysteries of the universe, time may no longer be the simple, linear experience we once thought it was. Instead, we might come to see it as a flexible, multidimensional concept that interacts with space, gravity, and even consciousness in ways we are only beginning to understand. This new view of time could reshape not just science and technology, but the very essence of what it means to be human, offering us new possibilities for growth, exploration, and connection in the vast, ever-unfolding tapestry of existence. If we entertain the idea that future events might be shaped by changes in the present or even past, ideas that echo theories of time travel, we find ourselves stepping into a realm where the very nature of time and morality collide. Suddenly, every decision we make carries an immense weight, not just for ourselves, but for generations yet to come. What if our actions right now hold the power to alter the very fabric of time? This concept challenges us to reconsider the responsibility we bear with every choice we make, imposing a profound moral duty on our shoulders. This intersection between time and ethics compels us to reflect on our decisions in a deeper, more intricate way. Are our choices truly fixed, as we often believe, or are they part of a far-reaching, complex pattern that stretches across time far beyond the scope of our immediate experiences? This idea sparks an existential inquiry into the nature of our agency. Are we simply following a timeline, or are we actively shaping it? At the heart of this exploration lies the question of how our actions ripple through time. Each moment in our lives may not just affect the here and now, but may also resonate across the generations to come. If we perceive time not as a rigid linear progression, but as something more fluid, even illusory, it encourages us to adopt a more empathetic and responsible approach to the way we live. By understanding time in this way, we are invited to reframe our ethical considerations, placing our decisions within a much broader, cosmic context. Reconceptualizing time opens a door to an array of fascinating questions about life, existence, and the very structure of the universe itself. Traditionally, we view time as a linear sequence. The past flows into the present, and the present unfurls into the future. But if we entertain alternatives, like cyclical or nonlinear models of time, we are forced to reconsider fundamental aspects of reality. If time is not a straight line, does that imply that past lives exist or that the future is already predetermined? This shift in perspective invites us to ask whether we are truly free to make choices, or if the path we tread is already laid out, hidden from our view. Such ideas often provoke a sense of unease. If time is capable of looping or warping, can we truly claim to have free will? Are we just following a script that we cannot perceive? This notion leads to a deep, often unsettling contemplation of our place within time and the very nature of human agency. If our choices are not entirely our own, how do we reconcile our sense of self-determination with the possibility of a predestined timeline? As we grapple with these complex concepts, we also confront deeper questions about the nature of the universe itself. Physics tells us that time is relative. What does this mean for our reality? Does it imply that there are truths, facts, or aspects of existence that exist outside of our limited, linear experience of time? Perhaps there are dimensions or truths that we cannot access, waiting in the vast, untapped expanses of the cosmos, just beyond the reach of our understanding. In contemplating these ideas, we find ourselves questioning not just our place in the universe, but the very nature of existence itself. Are we simply witnesses, passive travelers through time, watching events unfold as they will? Or are we active participants in a grand cosmic dance, where each moment holds untold significance? This question shifts our perspective, encouraging us to reflect more deeply on our lives, our choices, and the impact we have on the world around us. When we expand our view to include the universe's immensity, its countless stars, galaxies, and possible worlds, the contrast between our tiny existence on a single planet and the vastness of space becomes strikingly clear. On one hand, this perspective can make our individual lives feel insignificant, like a fleeting moment in the grand span of eternity. Yet, on the other hand, it can make every life seem profoundly meaningful. In the face of an infinite cosmos, our actions, however small, gain a kind of preciousness, because we are acutely aware of the fleeting nature of our existence. This realization about the brevity of life often sparks a desire to make a lasting impact. It propels us to contribute to something greater than ourselves, to leave behind a legacy that will resonate beyond our time on Earth. Whether it's through scientific discovery, artistic expression, or acts of kindness, we are driven to ensure that our lives have meaning to life, that they leave an imprint on the world, or perhaps even on the universe itself. At the same time, this awareness of our smallness encourages collective aspirations. Humanity as a whole begins to look beyond the individual and towards the survival and thriving of our species. We are drawn to the idea of uniting in exploration and knowledge, of reaching out into the vast, uncharted expanse of space, seeking not just to survive, but to understand. Our shared journey as we strive to explore and unlock the mysteries of the cosmos reflects our innate desire to connect with something larger than ourselves, to become part of a collective narrative that stretches beyond individual lives. As we venture into the unknown, questions about our purpose inevitably arise. Why do we seek to understand the universe? What drives us to push beyond the confines of our earthly existence and reach for the stars? These inquiries open the door to reflection on how we wish to be remembered. What legacy do we wish to leave behind? The vast, uncharted universe can stir a deep sense of wonder, but it also magnifies the significance of our choices and actions, urging us to cherish every fleeting moment. Moreover, the scale of the cosmos raises profound questions about our role within it. When we consider the billions of galaxies, each filled with billions of stars and potentially habitable planets, we are reminded of just how small we are in the grand scheme of things. And yet, paradoxically, this recognition can also make us feel part of something much larger, something vast, mysterious, and interconnected. We are left wondering, if life exists elsewhere in the universe, what does that mean for our own significance? If extraterrestrial life does exist, are our experiences truly unique, or are they simply one thread in a much larger, interconnected web of existence? This possibility can be humbling, suggesting that our place in the universe is not as singular as we might have thought. It might reduce the sense of being destined for a specific, grand purpose in the narrative of existence. However, there is another side to this realization. The idea that we are part of a vast community of life could also elevate the significance of our actions. Our choices, our ethics, our contributions, all might matter in ways we cannot fully comprehend, each moment woven into a greater collective journey that transcends the boundaries of time and space. In the end, these questions about time, free will, the nature of existence, and our place in the cosmos serve to remind us that in spite of our smallness in the vast expanse of the universe, we are connected to something much larger. Our lives, our choices, and our actions, no matter how fleeting, hold a profound significance in the great unfolding story of existence. And perhaps it is this realization that can help guide us toward a more thoughtful, intentional life, one that seeks not just to survive, but to contribute meaningfully to the cosmos we are a part of. The mysteries of the universe have long provoked not only curiosity, but deep contemplation about our place within it. The theories surrounding the ultimate fate of the cosmos are particularly captivating, urging us to explore profound questions about time, existence, and destiny. One of the most disconcerting possibilities is that everything could end in entropy, where all matter and energy become uniformly distributed, rendering the universe a cold, stagnant expanse. This scenario raises profound questions about the enduring nature of life itself. If everything will eventually dissolve into an unchanging state, what does it mean for the purpose and meaning we strive to create in our lives? In the face of such vast and impersonal forces, we are compelled to confront our own personal quest for meaning. How do we reconcile the inevitable end of everything with our desire for significance? The contemplation of the universe's entropic fate leads us to examine whether life carries a predetermined purpose or whether meaning is something we construct for ourselves through choices and experiences. This ongoing reflection serves as a reminder that while the universe operates on an incomprehensibly large scale, each individual is responsible for finding and cultivating their own purpose. The search for meaning, in this sense, becomes not only an intellectual pursuit, but a deeply personal journey, marked by exploration, connection, and the ongoing pursuit of knowledge. Through this lens, we may begin to see that purpose is not a static, preordained construct, but something we actively shape through our lives and relationships. The challenges posed by the universe's vastness may in fact enhance our understanding of our personal significance, inspiring us to focus on what we can control, the choices we make, and the people we love. As we confront these existential questions, we may find that the pursuit of understanding, rather than yielding definitive answers, enriches our experience and fosters a deeper connection to the world and each other. In addition to these reflections on meaning, the concept of time offers another fascinating avenue for exploration. Time, often seen as a linear progression from past to future, can feel like a relentless force pushing us toward inevitable deadlines and responsibilities. This rigid perception of time can leave us feeling overwhelmed, trapped in a cycle of obligations and future anxieties. However, when we shift our understanding of time to embrace its more fluid and dynamic qualities, we begin to see the potential for a deeper, more meaningful engagement with our lives. Consider those moments in life that seem to stand still, when joy, love, or connection fill our experience. These instances defy the conventional passage of time, feeling timeless in their intensity. In such moments, time appears to stretch or even disappear entirely, allowing us to be fully present and attuned to the richness of the experience. If time is not simply an unyielding forward march, but a collection of meaningful experiences, then we can cultivate a deeper appreciation for the present, savoring each fleeting moment instead of rushing through life. Embracing time as an illusion, or at least as something less rigid than the linear model we typically use, opens up the possibility for a profound shift in perspective. We become less concerned with what lies ahead or with the weight of what is past, and more engaged in appreciating the here and now. This mindset fosters mindfulness, a deeper awareness of the present moment, and encourages us to focus on the relationships, experiences, and emotions that truly enrich our lives, rather than the mere passage of time itself. In doing so, we not only cultivate gratitude, but also experience a more authentic, connected existence. Alternative theories of time present even more radical reimaginings of how we understand our reality. For centuries, time has been seen as a linear progression, a steady march from past to present to future. But a growing body of thinkers now proposes that time may not be as absolute as we have always assumed. Instead of a uniform shared experience, time might be deeply personal, influenced by our motion, our location, and even the forces of gravity. From this perspective, time might stretch or compress depending on where we are and how fast we are moving. This challenges the very notion of a universally fixed timeline, opening the door to entirely new ways of understanding our experiences. Another compelling theory envisions time not as a continuous flow, but as a multidimensional landscape filled with peaks and valleys of moments, each offering unique paths to explore. Rather than moving inexorably from one moment to the next, we might be navigating a vast, interconnected tapestry of potential experiences, each available to us depending on the choices we make. In this vision, the future is not a singular fixed course, but a landscape of possibilities that we can traverse. Some even suggest that all moments in time, past, present, and future, might exist simultaneously, like a vast, ever-expanding network of events and decisions. This raises fascinating questions. If every moment exists at once, how do our actions and choices shape the unfolding of the universe? In such a model, time ceases to be an isolated experience for each individual and becomes part of a greater, more intricate web. Each decision we make, each path we take could ripple across the continuum, weaving together different outcomes in a much larger narrative. These theories challenge our basic assumptions about reality and invite us to question how we perceive existence itself. They offer us a glimpse into new realms of understanding, realms that lie far beyond our conventional frameworks of thought. In the intersection of science and philosophy, time becomes a complex, dynamic phenomenon, a source of endless wonder and inquiry that invites us to reconsider our place in the universe. In addition to these alternative conceptions of time, some philosophers and scientists argue that time may be an illusion created by human consciousness itself. In this view, time is not a fundamental feature of the universe, but a construct we experience due to the way our minds process memory and anticipation. If time is merely a mental phenomenon, this raises intriguing questions. What does it mean for reality if time itself is not an objective feature of the world, but rather a subjective experience? Such radical ideas about time open the door to even more speculative possibilities, including the potential for time travel. While scientific theories suggest that time travel might be possible under specific conditions, through the manipulation of space-time or the existence of wormholes, this concept brings with it a host of philosophical dilemmas. Could we alter the past, and if so, what consequences might arise? Would such changes create new timelines, diverging from the one we know? These questions blur the line between science and philosophy, exploring the nature of free will, causality, and the very fabric of reality itself. Finally, there are those who suggest that time behaves differently depending on the context in which it is experienced. For instance, near massive objects like black holes, time appears to slow down dramatically compared to regions where gravity is weaker. This suggests that our experience of time is not only shaped by our movement through space, but also by the cosmic forces that govern the universe. In such a framework, time is not merely a personal experience, but a force influenced by the very structure of reality itself. These fringe ideas challenge us to rethink the simplicity of our everyday understanding of time. They invite us to explore the deep intersections between science and philosophy, pushing the boundaries of our knowledge and expanding our comprehension of existence. By embracing these radical perspectives, we open ourselves to new ways of thinking about time, space, and the cosmos, ways that may radically alter our understanding of reality itself. The exploration of these theories is not only a scientific endeavor, but a deeply philosophical one that invites us to reconsider the very nature of existence and our place in the vast, ever-expanding universe. When science challenges established paradigms, it often leads to radical new ways of thinking. Consider how the once radical idea of an expanding universe is now a cornerstone of modern astrophysics, prompting scientific inquiry into phenomena such as dark energy and the cosmic microwave background. By questioning the foundational assumptions of their field, scientists have opened up entire new realms of exploration. Similarly, the possibility that life could exist in extreme conditions on other planets was once a fringe idea, but today, it drives astrobiology research, with missions launched to explore environments once thought inhospitable to life. Such bold shifts in scientific thinking are not just intellectual exercises. They have profound implications for our understanding of the universe and our place within it. As we continue to question, explore, and challenge the very foundations of our knowledge, we embark on a journey of discovery that may one day reshape our understanding of reality itself. Radical perspectives in science have always played a critical role in pushing the boundaries of human knowledge. They serve as bridges between different scientific fields, encouraging collaboration in ways that might seem unthinkable at first glance. By applying concepts and principles from one discipline to another, these perspectives foster groundbreaking innovation. For instance, the application of physics to solve biological puzzles is a prime example of how interdisciplinary approaches can unlock novel solutions. This blending of fields often leads to discoveries that would be impossible within the limitations of traditional siloed thinking. In fact, the embrace of radical perspectives is not merely a tool for innovation. It is the very engine of scientific progress. By challenging established paradigms, scientists can venture into new realms of possibility, experimenting with ideas that have the potential to reshape our understanding of the universe. This spirit of bold inquiry has led to some of the most transformative discoveries in history. Whether it's exploring the mysteries of the cosmos or uncovering the underlying principles of life itself, it's this willingness to ask daring questions and entertain unconventional theories that sparks the innovations that drive science forward. Take, for example, the exploration of time, an area of study that presents both extraordinary opportunities and profound challenges. Venturing beyond traditional views of time has the potential to yield discoveries that could completely alter the way we think about the universe. Unconventional theories of time could not only deepen our understanding of the nature of gravity and its relationship to time, but they could also reveal unknown connections between various realms of physics, such as quantum mechanics and general relativity. These connections might even lead to the development of new technologies or provide a clearer understanding of cosmic phenomena like black holes, dark matter, and the origins of the universe itself. However, the pursuit of radical ideas does not come without its pitfalls. Some unconventional theories may seem far-fetched, and their speculative nature can lead to confusion, misinterpretation, or even a waste of resources. When these ideas contradict well-established scientific principles, they risk derailing progress, causing researchers to chase after concepts that are ungrounded or not yet fully understood. Furthermore, radical theories can often be met with resistance from the scientific community. Established scientists and institutions may be skeptical, making it harder for these ideas to gain the support needed for further investigation. In light of these challenges, it is essential for the scientific community to strike a delicate balance. While the exploration of radical ideas is crucial for progress, it must be done with a disciplined approach. These ideas should be rigorously tested through observation and experimentation, ensuring they stand up to the scrutiny of the scientific method before being accepted. In this way, radical theories can be explored in a way that minimizes risks while maximizing the potential for discovery. History provides a powerful reminder of the value of open-mindedness in scientific inquiry. The evolution of our understanding of time itself offers a compelling case. In the 17th century, Isaac Newton defined time as a constant, unchanging dimension. However, in the early 20th century, Albert Einstein's theory of relativity turned that understanding on its head. Einstein proposed that time is not a fixed, universal constant, but rather a flexible, relative concept, influenced by speed and gravity. This radical departure from Newtonian physics completely transformed our understanding of the universe. It demonstrated the power of embracing new ideas and the profound shifts that can occur when we are willing to question established norms. Just as Einstein's theory challenged the conventional understanding of time, modern research continues to entertain bold and radical theories. Ideas such as time travel, the multiverse, and the nature of time itself are all examples of concepts that are rooted in the exploration of new, often controversial perspectives. But it is essential to remember that while such theories open new doors, they must be rigorously tested and subjected to the scientific method. Skepticism, in this context, is not a roadblock, but rather a vital part of the process that ensures scientific reliability. Without the careful vetting of ideas, we risk indulging in unfounded speculation that can undermine the integrity of scientific progress. In the quest to understand time, we are not simply pursuing abstract theories. We are also exploring the deeply personal and subjective experience of time itself. One of the most fascinating aspects of human existence is how time is perceived differently based on emotions, experiences, and mental states. Consider a personal moment in your life when time seemed to stretch on forever, a day spent with loved ones where every second was filled with joy and laughter. Now, contrast that with the feeling of a tense conversation or waiting for something important to happen, where even a few minutes can seem agonizingly long. These moments demonstrate that time is not a rigid, objective measurement. Instead, it is a fluid, dynamic experience, shaped by our own perceptions and emotions. Our recollections of past events also reveal this flexibility in how we experience time. Certain memories seem so vivid they feel as though they occurred just yesterday, while others fade into distant and hazy recollections. This inconsistency in memory suggests that time is not purely a linear progression, but rather something that is deeply intertwined with our mental processes. Our minds often distort time, stretching and compressing it based on the significance of the experiences we go through. Time feels especially elastic during moments of intense emotion or novelty. Think about a moment of pure joy or excitement, perhaps the thrill of a new adventure or a celebration with friends. In such moments, hours seem to fly by in an instant. On the other hand, during times of anxiety, sadness, or waiting, even the shortest stretches of time can feel excruciatingly long. These subjective experiences suggest that our emotions play a profound role in shaping how we perceive time, bending it to fit the emotional landscape we are navigating. Equally intriguing is the way time is perceived during routine or mundane activities. When we engage in repetitive tasks, like commuting to work or doing household chores, the passage of time often seems to blur, with the day feeling as though it is passing quickly. But when we find ourselves in unfamiliar situations or new environments, the opposite happens. Time seems to stretch, and our experiences become richer and more vivid. The brain absorbs more information in new contexts, which makes time seem fuller, creating a perception of it lasting longer. In the grand scheme of things, these personal experiences highlight the illusion of time as a rigid, unchanging force. Instead, time is a concept that is deeply shaped by our subjective experiences, our emotions, memories, and mental states. This realization is not only fascinating, but is crucial for our understanding of the nature of reality itself. By embracing radical perspectives and exploring the illusory nature of time, we can continue to push the boundaries of science, discovering new ways to understand both the universe and our place within it. As we navigate through life, time presents itself not as a rigid, fixed entity, but as something far more malleable, shaped by our experiences, emotions, and perceptions. Consider moments when you're completely immersed in the present, moments that heighten your awareness and change your understanding of time's flow. Think about the exhilaration of travel, the thrill of extreme sports, or even the quiet intensity of climbing a mountain. In these moments, the clock fades away. You're no longer concerned with time in the conventional sense. Instead, your awareness sharpens. Every second becomes significant, and time seems to stretch in an almost surreal way. This perception contrasts sharply with the mechanical passage of time we're accustomed to, where the tick-tock of the clock remains constant and unaffected by how we experience it. Our personal engagement, however, can radically alter our sense of time. Take, for instance, the experience of exploring a new city. The unfamiliar sights, sounds, and smells fully engage your senses, allowing you to be absorbed in the present. The hours slip by unnoticed as you savor every moment, every corner, and every interaction, making the day feel longer, richer, and more meaningful. This expanded perception of time is not limited to travel or adventurous activities. It can occur in any context where our focus is sharpened, where we are present and engaged. But there's a profound element to this perception that is often overlooked: age. Time, as we experience it, changes drastically throughout our lives. For children, each passing year represents a significant portion of their lives, making the flow of time feel slower and fuller. To a child, a single year can feel like an eternity, a never-ending stretch of discovery and growth. As we grow older, however, time seems to speed up. Each year shrinks in comparison to the years that have come before. This compression is not merely an illusion, but a psychological reality, linked to how we process and perceive the passing of time. The years become increasingly similar, filled with routine and familiarity. Time, once an expansive and exciting frontier, becomes a series of moments that blend together in a way that feels faster, more fleeting. The difference in how time is perceived from youth to adulthood is a powerful insight into the evolution of our relationship with time, highlighting the emotional and cognitive shifts that accompany aging. People often describe certain moments as being outside the normal flow of time, moments when time seems to either stop or accelerate. Picture the thrill of a dramatic sports game, a moment when every pass, every move feels so intensely significant. Or think of an intimate conversation where the world seems to fall away and the moment becomes everything. In these instances, time appears to stretch, as though it has slowed down, giving us the opportunity to absorb every detail, every emotion, every sound. It's almost as if the world itself has paused, holding its breath, allowing everything around us to become more vivid and meaningful. On the other hand, there are the moments when time seems to fly by, those days filled with laughter, joy, and fun. A holiday with friends, a sunny afternoon at the beach, or a spontaneous adventure. In these instances, people often express disbelief at how quickly the hours seem to pass. It's as if time is racing away, slipping through our fingers before we can grasp it. This sensation often arises when we are so fully engaged in an activity, so absorbed in the moment, that time becomes irrelevant. The more we enjoy ourselves, the less we notice time's passage, and the quicker it seems to go. This phenomenon can be explained through the brain's processing of information. During intense, focused situations, whether a thrilling event or an emotionally charged moment, the brain works overtime, storing memories in vivid detail. This heightened state of awareness often gives the illusion that time has slowed down. Conversely, during moments of routine, when the brain's activity is less intense and less engaged with new stimuli, time seems to slip by unnoticed. The brain doesn't register time in the same way, leading to the perception that it has flown by in the blink of an eye. It's clear then that our perception of time is not simply a reflection of the hours that pass, but a deeply subjective experience. It's shaped by our mental engagement and the emotional weight of our experiences. Time is in many ways an elastic concept, stretching or compressing depending on the intensity of the moments we live through. And this elasticity can be influenced by many factors, not least of which are our emotions and the situations we find ourselves in. Think of the difference between moments of intense joy or excitement, like riding a roller coaster or celebrating a milestone, and those filled with anxiety or discomfort. In moments of happiness, time often flies by, as if the joy and adrenaline are in a race against the clock. But in moments of stress, the opposite happens. Time seems to drag, each minute stretching into what feels like an eternity. Sitting in a doctor's office, waiting for news that could change everything, the minutes seem interminable. It's not just the passage of time that feels different, it's the way we experience it emotionally. Scientific research has shown that our perception of time is influenced by how engaged we are in an activity. Studies suggest that when we are deeply focused or experiencing something novel, time seems to pass more quickly. But when we're engaged in monotonous or routine tasks, our perception of time slows down. These subjective experiences, how we feel time stretching or contracting, are more than just curiosities. They are reflections of how our brain processes our emotions, attention, and sensory input. Moreover, cultural perspectives also play a significant role in how we perceive and value time. In some cultures, time is seen as flexible and fluid, where relationships and experiences are prioritized over rigid schedules. In contrast, other cultures place a premium on punctuality, efficiency, and structure, treating time as something fixed and measurable. These cultural variations reflect how the perception of time can change based on context and individual experiences. They remind us that time is not merely a universal concept. It is interpreted and valued differently across societies. At its core, time is more than just a sequence of ticking seconds. It is a deeply personal experience shaped by our emotions, cultural background, and the specific moments we live through. From the joy of a child experiencing a summer vacation to the tension of waiting for life-changing news, time's passage is never the same for anyone. And as we grow older, our understanding of time shifts, making us reflect on how we have changed in relation to it. As we listen to others share their stories, moments where time seemed to stand still or race away, we gain a new appreciation for how flexible and fluid time can be, and how deeply intertwined it is with the richness of life's experiences. These personal reflections on time, whether shared in casual conversation or explored in deep interviews, provide invaluable insights into how we each relate to the passage of time. A fleeting moment for one person might be a cherished memory etched in their mind, while for another, that same moment could feel like it passed in the blink of an eye. Such stories allow us to see that time, though measured in seconds, minutes, and hours, is ultimately defined by the experiences and emotions that shape our lives. In this way, time is not simply something that happens to us. It is something we live, feel, and remember in profoundly different ways. The power of testimonials lies in their ability to evoke resonant emotions, establishing a shared connection between the storytellers and the audience. When individuals recount how time has shaped their personal journeys, it transforms the concept of time into something more than a mere measure of moments. It becomes a force, not just a passage, but an experience, molded by the intricacies of context, memory, and emotion. This exploration of time moves beyond abstract theory and invites the viewer to reflect on their own relationship with it, encouraging a deeper engagement with the subject. As different voices articulate their unique experiences, viewers are prompted to examine their perceptions, potentially shifting how they understand time in their own lives. The documentary invites us to consider that time is not a singular, fixed progression, but rather a complex, multifaceted phenomenon, one that defies easy categorization. It challenges the conventional notion of time as a constant linear force, instead emphasizing how our emotional and cognitive responses shape our experience of it. This leads to a richer, more nuanced understanding, one that connects the individual to the universe in a deeply personal way. Through this lens, time is not merely a ticking clock, but a lived experience, intertwined with every moment, every choice, and every memory. In understanding time, interdisciplinary research offers profound insights, blending perspectives from diverse fields to address this elusive concept. The study of time is one of the best examples of such a collaborative approach. Fields as varied as physics, philosophy, neuroscience, and psychology each provide their own lens through which we can better comprehend the nature of time. Each discipline adds a piece to the puzzle, creating a more comprehensive picture of what time is and how it operates. Physics, for instance, offers us a view of time that is deeply interwoven with space and matter. According to the theories of relativity, time is not an absolute, immutable entity. It stretches, compresses, and bends based on the influence of gravity and speed. When you approach the speed of light, time itself behaves differently. distorting in ways that fundamentally challenge our conventional understanding. This revelation suggests that time operates on a universal scale, transcending our human perception of it as a steady, predictable flow. In contrast, philosophy invites us to question the very nature of time. Is time a universal truth, existing independently of human observation, or is it something that only takes shape in relation to the observer? Philosophers have long debated whether time is a fixed entity or an experience shaped by the human mind. And these inquiries push the boundaries of both our scientific knowledge and our personal understanding of time's significance in life. Neuroscience provides yet another dimension to this inquiry. By studying how the brain processes time, we discover that our perception of it is far from uniform. Time is, in fact, subjective. Our experience of it can be influenced by factors like emotion, attention, and even cultural context. When we feel joy, time seems to fly by. When we experience sadness or boredom, it stretches on endlessly. These findings suggest that time is not just a fixed external measure, but a personal, fluid experience that varies from one individual to another. Neuroscience thus offers a bridge between the scientific and the human experience, helping to reconcile the objective, measurable aspects of time with its more intangible, personal qualities. When these different fields, physics, philosophy, and neuroscience, collaborate, they create a richer, more nuanced understanding of time. By examining how we interpret time through cognitive processes and how these interpretations interact with its physical properties, researchers are able to build a more integrated theory. This approach not only allows us to quantify time, but also to appreciate its deeper effects on our lives, helping us understand not only how time functions in the universe, but how it shapes our experiences as human beings. The blending of science and human experience provides us with a comprehensive framework that transcends individual disciplines, shedding light on the complexity of time in ways that a single field alone could never achieve. Art and science, though often viewed as separate realms of inquiry, often join forces in compelling and innovative ways to explore the mysteries of time. While science seeks to define and measure time through observation and data, art allows for a more subjective, emotional interpretation, capturing the essence of time as it exists in the human experience. Together, they enrich our understanding of this elusive concept, inviting us to experience time not just as a scientific phenomenon, but as an emotional and philosophical one as well. In the realm of visual art, for example, artists have long used various techniques to represent the passage of time. A single painting might capture a moment frozen in time, yet evoke a sense of what came before and what will come after. These visual stories speak to the universal human experiences of change, loss, and memory. Impressionist artists, for instance, often portrayed the fleeting qualities of light and movement, subtly referencing time's transient nature. The very act of creating such works serves as a meditation on the passage of time, offering viewers an invitation to reflect on their own experiences of impermanence. On the scientific side, time is examined through the lenses of physics and cosmology. Time is not a universal, unchanging constant, but something that behaves differently depending on context. From the ticking of a clock to the vast ages that stretch across galaxies, time operates on a variety of scales. Concepts like time dilation challenge our everyday understanding of how time should flow, suggesting that it bends and stretches depending on speed, gravity, and perspective. This provides a fascinating paradox to our intuitive experience of time, as we come to understand that what seems constant and predictable to us is, in reality, much more fluid and dynamic. The intersection of art and science brings new dimensions to our understanding of time. Collaborative projects often pair scientific data with artistic expression, inviting the public to engage with time in new and innovative ways. Interactive exhibits might allow visitors to manipulate visual representations of time, allowing them to experiment with how time is perceived and understood. These creative endeavors encourage a hands-on, experiential learning process where viewers are not just passive recipients of information, but active participants in exploring the complexities of time. Through these collaborations, both science and art encourage us to rethink time, not only as a measurable quantity, but as a multifaceted experience that can be felt, seen, and even manipulated. Literature, too, offers a unique way to explore the concept of time. Through stories, essays, and poetry, writers examine time not just as a linear sequence of events, but as a rich tapestry of memory, experience, and anticipation. Time in literature is often portrayed as something fluid, not always bound to the clock's ticking hands. Characters might experience past, present, and future simultaneously, or the passage of time may feel distorted, speeding up or slowing down depending on the emotional or psychological states of the characters. These literary representations offer a deeper understanding of the human experience, allowing us to grasp the complexities of time as something much more than a linear, objective progression. By analyzing how authors manipulate time in their narratives, we can better understand the ways in which we, as individuals, perceive time in our own lives. Literature provides us with a window into the subjective experience of time, inviting us to explore its complexities and uncertainties. It also resonates with the scientific theories of time, particularly in relation to relativity, where time's flow is not a constant, but rather a variable phenomenon shaped by a wide range of factors. As literature and science continue to explore the nature of time, we gain a more holistic, human-centric understanding of this fundamental aspect of existence. Moreover, literary narratives often offer a mirror to the attitudes societies hold toward time, reflecting how different communities prioritize the past versus the future. These narratives illuminate how moments of change, however subtle or grand, can reshape the collective perception of time, urging us to reconsider how we relate to it. In many ways, literature holds a mirror to the passage of time, showing us that it is not merely a sequence of moments, but something deeply entwined with culture, values, and human experience. Altogether, by integrating these literary perspectives with scientific inquiry, we create a dialogue that is richer and more profound. It encourages us to look beyond the confines of mathematical models and tangible measurements, pushing us to engage with time not only as a concept to be quantified, but as something that resides in our very essence. This interdisciplinary approach, which combines the rigor of science with the depth of literature, helps bridge the gap between the objective understanding of time and the deeply personal, often philosophical interpretations that literature so eloquently explores. Ultimately, by weaving together literary analysis with scientific discourse, we open up a broader, more nuanced understanding of time, not just as a physical phenomenon, but also as a force that shapes the way we live, think, and experience the world. This synergy fosters a deeper appreciation for both realms, showing that time is not simply a metric, but a profound and vital element of human existence, one that extends beyond the clock and calendar and into the core of our lives, stories, and cultures. The exploration of time through a cross-disciplinary lens offers a fascinating array of perspectives. Time is not just a concept defined by physicists or philosophers. It is something that touches every corner of human experience. Fields like physics, philosophy, psychology, and even art examine time from unique vantage points, each providing valuable insights into the multifaceted nature of this elusive force. In physics, time is often viewed as a dimension intricately woven into the fabric of space. This is seen in the concept of space-time, where time and space are inextricably linked, and time is not merely a backdrop, but an active participant in the universe's structure. In this view, time influences movement and gravity, shaping the very way celestial bodies interact. This perspective allows scientists to study time as a dimension that can bend and stretch, challenging our conventional notions of its unyielding forward march. Philosophy, on the other hand, delves into the very nature of time itself, probing questions about its existence and essence. Is time real, or is it merely a construct of human perception? Philosophers have long debated whether time is a linear progression from past to present to future, or if the past, present, and future exist simultaneously in some profound way. These discussions lead to even deeper inquiries, such as whether our perception of time is merely a trick of the mind, or whether time itself is a tangible, independent entity that exists outside our perception of it. Psychology, meanwhile, connects to time through the intricacies of human experience. The way we perceive the passing of time is deeply influenced by our emotional states and cognitive processes. For instance, time seems to fly when we are engaged in something enjoyable, yet it drags on interminably during moments of boredom or stress. This subjective experience reveals that our emotional states and mental focus can profoundly alter our perception of time. Such insights have far-reaching implications, helping psychologists better understand the role of time in mental health, decision-making, and the shaping of personal identity. Art brings yet another dimension to the study of time, particularly through its use as a narrative tool. Artists have long employed time as both a subject and a medium, exploring its passage and its impact on memory, continuity, and change. A painting, for example, can capture a single fleeting moment, freezing it in time forever. In contrast, a video or film can convey the movement and progression of time, allowing audiences to experience time in a more dynamic, fluid manner. Through their work, artists explore how time can be represented, experienced, and remembered, often prompting reflection on the interplay between permanence and impermanence. Each of these disciplines, whether science, philosophy, psychology, or art, brings a unique set of insights that help to enrich our understanding of time. When we weave these perspectives together, we see that time is far from a simple linear sequence of events. Rather, it is a complex, multifaceted phenomenon that affects and is affected by our existence, our thoughts, and our creativity. This interconnectedness between disciplines helps us grasp the full scope of time's influence, making it a more engaging and thought-provoking subject for exploration. Furthermore, exploring time through a broad intellectual framework offers several benefits that deepen our understanding of time and its implications across various fields. One significant advantage is that it encourages a holistic view of time, not just as a measurement, but as a fundamental aspect of existence. By connecting insights from physics, philosophy, biology, and other fields, we can begin to understand how time influences everything from the origins of the universe to the rhythms of human behavior. Moreover, placing time within this wider context invites interdisciplinary collaboration. Scientists, philosophers, historians, and artists, each with their own distinct approach to time, can come together to share their perspectives. This collective engagement can lead to innovative solutions to complex problems, as well as a deeper appreciation of how different cultures understand and relate to time. From the ways in which societies structure their daily lives to how they celebrate milestones and commemorate historical events, time is a key factor in shaping human civilization and culture. Acknowledging the complexities of time also enhances our understanding of related concepts such as change, memory, and consciousness. In psychology, for instance, the way we perceive the passage of time can have a profound effect on our mental well-being and on how we define ourselves over the course of our lives. Understanding these connections allows for the development of better emotional and cognitive support systems, helping individuals navigate the challenges that arise as they move through different stages of life. Finally, approaching time from an expansive intellectual perspective can spark curiosity and wonder. For students and scholars, exploring time as a concept that bridges multiple disciplines ignites a passion for discovery, inviting further investigation into the mysteries of existence. By encouraging a deeper engagement with time, this broad framework fosters critical thinking, creativity, and an enduring curiosity, all of which are essential tools for addressing the challenges of an ever-changing world. In sum, time is more than just a number on a clock. It is a deeply embedded element of our lives, woven into our culture, our relationships, and our understanding of the universe. By drawing from a variety of disciplines, we can begin to unravel the mysteries of time and appreciate the profound impact it has on all aspects of existence. Through this multidisciplinary approach, we not only expand our understanding of time, but also uncover its true significance as a central force in shaping the human experience.